Some places refuse to hold north. Snoqualmie Pass sits at 3,022 feet elevation in the Cascade Range, where Interstate 90 cuts through mountains that have funneled travelers between Seattle and eastern Washington since before the highway existed. The Snoqualmie people knew these ridges as a boundary between worlds, a place where the usual rules didn't always apply. When the Milwaukee Road Railway punched through in 1909, workers reported compass irregularities that engineers attributed to local iron deposits. When the highway came in 1915, surveyors noted the same disturbances in their field reports. By the time Interstate 90 replaced the old highway in 1978, the magnetic anomalies had become part of the surveying process, expected, documented, and quietly ignored. The pass itself is unremarkable in appearance. Dense Douglas fir and western hemlock crowd the slopes. In winter, snow accumulates in depths that regularly close the highway. In summer, hikers use the area as a staging point for longer wilderness treks. The terrain is steep but accessible, crossed by old logging roads and unmarked trails that date back to the Civilian Conservation Corps. Nothing about the landscape suggests the kind of precision that would later be documented. Nothing except the circles. On August 14, 1983, a Washington State Department of Transportation survey crew was conducting routine magnetic field mapping for a proposed highway expansion. The team leader was a civil engineer named Robert Kasparek, 41 years old with 17 years of surveying experience across 6 western states. His crew consisted of 3 technicians, Maria Delgado, Timothy Oakes, and Jennifer Whitmore. They were using standard proton precession magnetometers, equipment reliable enough to detect buried pipelines and geological formations with consistent accuracy. At approximately 2:15 in the afternoon, Delgado noticed her compass behaving erratically. The needle was rotating counterclockwise in smooth, continuous circles. She called Kasparek over. His compass did the same. So did Oakes's. So did Whitmore's. They were standing in a clearing roughly 600 feet south of the highway, accessible by a Forest Service access road that had been gated since 1976. The clearing measured approximately 40 feet in diameter. Every compass within that circle spun counterclockwise. Every compass outside the circle pointed north normally. Kasparek documented the coordinates: 47.384 degrees north, 121.412 degrees west. He marked the perimeter with surveying flags. The crew spent the next 3 hours testing the phenomenon with multiple instruments. The magnetometers showed field strength variations that didn't correspond to any known geological formation. The readings were consistent, but impossible. Magnetic north appeared to be rotating around the clearing's center point at a rate of approximately 4 revolutions per minute. The crew returned the next day with additional equipment. The phenomenon persisted. Kasparek filed a formal incident report with the Department of Transportation on August 16th. He also contacted the United States Geological Survey Office in Seattle. A geophysicist named Dr. Rajesh Kulkarni agreed to visit the site. Kulkarni arrived on August 18th with a graduate assistant named Michael Brennan. They brought more sophisticated equipment: cesium vapor magnetometers, GPS units, and seismic sensors. Kulkarni later described the clearing in his field notes as magnetically incoherent. The compasses continued to spin. The magnetometers recorded data that Kulkarni said violated basic principles of terrestrial magnetic field behavior. The phenomenon attracted attention from other researchers. By August 22nd, a team from the University of Washington's Earth and Space Sciences Department had joined the investigation. Professor Helena Voss, a geophysicist specializing in paleomagnetism, brought equipment capable of measuring magnetic field variations down to fractions of a nanotesla. Her instruments confirmed what the simple compasses had shown. Something in that clearing was creating a rotating magnetic field. Voss documented her observations in a preliminary report dated August 25, 1983. She noted that the magnetic anomaly appeared to originate from a depth of approximately 15 to 20 feet below the surface. She also noted something else. The rotation was slowing. On August 14th, compasses had completed roughly 4 rotations per minute. By August 25th, the rate had decreased to approximately 3 rotations per minute. Local residents began visiting the site. A hiking guide named Thomas Riley brought clients to see the phenomenon. A journalist from the Seattle Times, Patricia Moreno, wrote a brief article that appeared in the August 27th edition. The article mentioned the spinning compasses and quoted Kasparek describing the clearing as unlike anything in 17 years of survey work. The Forest Service closed the access road on August 29th. A spokesperson cited safety concerns related to increased foot traffic. Researchers were given continued access with special permits. On September 2, 1983, the phenomenon stopped. Compasses pointed north. Magnetometers showed normal readings. The clearing became magnetically ordinary. The entire event had lasted exactly 19 days. Voss submitted her final report to the USGS on September 9th. In it, she stated that the magnetic anomaly had no clear geological or artificial source and recommended further investigation. Kulkarni submitted a separate report with similar conclusions. Both researchers requested funding for a comprehensive geological survey of the area, including core samples and ground-penetrating radar analysis. The funding was never approved. The USGS response, dated October 3, 1983, thanked both researchers for their work and stated that, given the transient nature of the reported phenomenon and the absence of ongoing anomalous readings, further investigation is not warranted at this time. What happened next took longer to discover. In 1997, a graduate student named Angela Kowalski was researching historical geological surveys of the Cascade Range for her dissertation at Portland State University. She was working through archived USGS field reports when she found a surveying document from 1952. The document described a magnetic anomaly at Snoqualmie Pass, a circular area approximately 40 feet in diameter where compasses failed to maintain consistent orientation. The coordinates matched Kasparek's 1983 report within 10 feet. The 1952 report was stamped inconclusive and filed without follow-up. Kowalski kept searching. She found another report from 1967, authored by a Forest Service geologist named Warren Fisher. Fisher had documented unusual magnetic field behavior in the same location. His report included hand-drawn maps showing a circular area where compass readings were unstable and non-directional. The report was marked pending review, but showed no evidence that any review had occurred. Kowalski found a third report from 1979. This one was written by a Department of Transportation surveyor named David Ortega, who noted magnetic interference of unknown origin during highway maintenance surveys. Ortega's coordinates matched the others. His report included a recommendation for geophysical investigation by qualified specialists. The recommendation was never acted upon. Kowalski contacted the USGS to inquire about the historical reports. She was told that the documents were part of archived field surveys and had been digitized in the early 2000s as part of a general records preservation effort. When she asked why the reports hadn't been cross-referenced or flagged as potentially significant, she received no clear answer. She also tried to contact the original researchers. Kasparek had retired in 1995 and was living in Spokane. He agreed to speak with her by phone. He confirmed the events of 1983 and said he'd been surprised when no follow-up investigation occurred. He also mentioned something else. 2 months after the phenomenon ended, he received a letter from the USGS requesting that he not discuss the incident publicly. The letter cited ongoing investigation as the reason. No investigations ever took place. Voss had moved to a research position in Alaska. She responded to Kowalski's inquiry with a brief email stating that she no longer worked on that subject matter and declined to be interviewed. Kulkarni did not respond to multiple contact attempts. Kowalski expanded her search. She requested access to USGS Geological Survey archives from 1940 through 2000. The request was approved, but when she visited the Seattle Records facility in March 1998, she was told that several boxes of Cascade Range field reports from 1950 to 1985 had been transferred to a federal records center in Colorado for long-term preservation and cataloging. When she contacted the Colorado facility, she was informed that the specific boxes she requested were undergoing conservation assessment and would not be available for researcher access until further notice. In 2004, a hiking forum based in Washington State posted a thread about strange compass behavior near Snoqualmie Pass. 3 separate users reported experiencing the same phenomenon, compasses spinning without settling on north during hikes in the summer of 2003, and the reports were met with skepticism. One user suggested the hikers had been near power lines. Another mentioned iron deposits. The thread eventually faded without resolution. Kowalski published her dissertation in 2006. It included a section on repeating magnetic anomalies in the Cascade Range. She noted the Snoqualmie Pass reports and their apparent suppression or neglect in official records. Her dissertation committee accepted the work without comment on that section. In 2012, the Washington State Department of Transportation conducted a geological survey for a proposed widening of Interstate 90 near Snoqualmie Pass. The survey included magnetic field mapping. The results were never published. A Freedom of Information Act request filed by a local environmental group in 2014 seeking the survey data was denied on the grounds that the information related to infrastructure security planning. The clearing still exists. The Forest Service access road remains gated. Occasionally, hikers find the site using GPS coordinates posted online. Some bring compasses. The compasses point north. The ground shows no signs of disturbance. Nothing suggests that anything unusual ever happened there or that it might happen again. What remains is a pattern. 4 documented incidents across 31 years. The same location, the same circular precision, the same institutional disinterest. And a question that nobody with access to the relevant data seems willing to answer. If magnetic anomalies like this occur regularly in the same place, what creates them? And why does the pattern repeat with such exactness? The archives remain sealed. The researchers have moved on. And somewhere in federal storage, 9 field reports describe something that officially never warranted further investigation, a circle that refuses to hold north, appearing and disappearing on a schedule that nobody has been allowed to fully document. Something beneath the deepest lake in America was counting. Crater Lake sits in the collapsed caldera of Mount Mazama, a volcano that destroyed itself in an eruption 7,700 years ago. The lake is 1,943 feet deep at its lowest point. No rivers flow in or out. The water is fed entirely by rain and snowmelt, filtered through volcanic rock until it achieves a clarity that allows visibility to depths of over 100 feet. The Klamath people considered the lake sacred, a place where the spirits of the sky and earth had fought until the mountain fell into itself. They rarely visited the rim. They never entered the water. The lake became a national park in 1902. By the 1930s, the Civilian Conservation Corps had built rim roads and observation points. Tourists came to photograph the impossible blue of the water. Scientists came to study its unique ecology, a closed system with no fish until they were introduced in the 1880s, no pollution, and water so pure it approaches distilled quality. By the late 20th century, Crater Lake had become one of the most studied bodies of water in North America. monitored by the USGS, the National Park Service, and multiple university research programs. The acoustic phenomenon began in the summer of 2009, though it would be months before anyone realized what they were hearing. On July 19, 2009, a wildlife biologist named Marcus Delacroix was conducting a survey of bird populations along the lake's western rim. He was using a directional microphone to record bird calls for species identification. At approximately 6:45 in the morning, his equipment picked up something else. A low-frequency tone that lasted 23 seconds rose and fell in what seemed like a deliberate pattern, then stopped. Delacroix noted the recording but attributed it to equipment interference or distant machinery. He was alone on the rim. The nearest road was over a mile away. There were no boats on the lake. He continued his survey work and thought nothing more of it. 3 weeks later, on August 11th, a park ranger named Sarah Kowalczyk was conducting a routine patrol near Cleetwood Cove, the only place where visitors are permitted to access the water directly. She was carrying a handheld radio. At approximately 7:02 in the morning, her radio emitted a burst of static, followed by a tone sequence that lasted roughly 20 seconds. The tone was low, rhythmic, and unlike any radio interference she'd encountered in 8 years of park service. She documented the incident in her daily log and mentioned it to the park's communication technician, who found no evidence of radio malfunction. The recordings continued sporadically through the fall of 2009. A geology graduate student named Priya Mehta, working on sediment samples from the lake bottom, captured the tones on underwater recording equipment in October. A group of amateur astronomers filming a meteor shower in November recorded the sequence on their video camera's audio track. By December, at least 6 separate individuals had documented the same phenomenon. A 23-second tone sequence, low frequency, seemingly originating from the lake itself. None of them had compared their recordings yet. None of them knew they'd captured the same thing. That changed in January 2010 when Delacroix attended a regional wildlife conference in Eugene, Oregon. During a conversation about field recording techniques, he mentioned the unusual audio capture from Crater Lake. Another attendee, an acoustic ecologist named Dr. Leonard Yamaguchi from Oregon State University, said he'd heard something similar while recording ambient sound at the lake in September. They compared their recordings. The tone sequences were identical, same frequency range, same duration, same pattern of rises and falls. Yamaguchi was intrigued. He specialized in bioacoustics and had spent 15 years recording natural soundscapes. He documented everything from whale songs to the subsonic rumble of earthquakes. The Crater Lake tones didn't match any natural phenomenon he recognized. The pattern was too structured, too repetitive. He began reaching out to other researchers who'd worked at Crater Lake. By March 2010, he'd collected 9 separate recordings of the tone sequence, captured by different people using different equipment between July 2009 and February 2010. Every recording was 23 seconds long. Every recording contained the same pattern. Yamaguchi submitted a preliminary analysis to the Journal of the Acoustical Society of America in April 2010. His paper described the recordings as non-random acoustic events of unknown origin and noted that the frequency range, between 45 and 65 Hz, was below the threshold of normal human hearing, but well within the range of recording equipment. He proposed 3 possible explanations: geological activity, biological sources, or artificial signals. He requested additional monitoring and study. The journal's response came in June. 3 lines unsigned on official letterhead. Thank you for your submission. After review, we have determined that the material does not meet our publication standards at this time. We encourage you to seek alternative venues for your research. Yamaguchi was confused. He'd published 17 peer-reviewed papers. He knew the submission process. The rejection was unusually terse, and it included no reviewer comments, a standard part of the process even for rejected submissions. He submitted the paper to Geophysical Research Letters in July. The response came in August. Same format, 3 lines, same wording, nearly verbatim. No reviewer feedback. By September 2010, Yamaguchi had collected 14 recordings of the tone sequence. He'd also enlisted help from colleagues in acoustics, geology, and seismology. They analyzed the recordings using spectral analysis, cross-correlation, and signal processing techniques. The results were consistent. The tone sequence was artificially structured. It contained harmonics and frequency relationships that didn't occur in natural geological or biological phenomena. Dr. Bethany Strand, a seismologist at the University of Washington, offered a comparison. Natural sounds, even complex ones like earthquake rumbles or volcanic tremors, have chaotic elements, she said in an email to Yamaguchi, dated September 28, 2010. These recordings show mathematical precision. The intervals between frequency shifts are exact. That doesn't happen in nature. Yamaguchi contacted the National Park Service in October 2010. He spoke with James Haverford, the park's chief of resource management. Haverford was familiar with the recordings. Several park employees had mentioned the strange tones over the previous year. He agreed to support additional acoustic monitoring and offered to help secure funding for a comprehensive study. In November 2010, Yamaguchi submitted a research proposal to the National Science Foundation. The proposal outlined a plan for long-term acoustic monitoring at Crater Lake using an array of underwater and surface recording stations. The goal was to determine the source, frequency, and pattern of the tone sequences. The requested budget was modest, $75,000 over 2 years. The proposal was declined in January 2011. The rejection stated that the project did not align with current funding priorities and that the phenomenon described was insufficiently documented to warrant dedicated study. Yamaguchi continued recording independently. By March 2011, he had 17 recordings. The tone sequence had occurred roughly once every 3 to 4 weeks since July 2009. The timing wasn't precise, but it followed a loose pattern. Then, in April 2011, the tones stopped. The last confirmed recording was made on April 9, 2011, by a park ranger named Thomas Ridley. After that date, no one captured the sequence again, despite continued monitoring by Yamaguchi and several volunteers. What had changed? In March 2011, the USGS had installed new seismic monitoring equipment at Crater Lake as part of a Cascade Range volcanic surveillance upgrade. The equipment included sensitive seismometers placed at multiple locations around the lake, including 2 underwater stations. The installation was completed on April 2, 2011, 1 week before the final recorded tone sequence. Yamaguchi inquired about the seismic data. He wanted to know if the new equipment had detected anything unusual. The USGS response, delivered by phone in May 2011, was brief. The seismic stations were functioning normally and had detected no anomalous activity. When Yamaguchi asked to review the raw seismic data from April, he was told that the information was restricted to authorized research personnel conducting volcano hazard assessment. He tried another approach. He contacted Haverford at the National Park Service and asked if there had been any changes to park operations or equipment that might explain the cessation of the tones. Haverford said he wasn't aware of any changes beyond the USGS seismic installation. He also mentioned, carefully, that he'd been advised by his supervisors not to discuss unconfirmed acoustic phenomena with outside researchers without prior approval. Yamaguchi submitted his findings to 3 more journals between June and October 2011. Each submission included the full set of 17 recordings, detailed spectral analysis, and documentation of the pattern. Each submission was rejected with minimal explanation. One rejection letter from Environmental Science and Technology included a single sentence beyond the standard decline. We recommend consulting with appropriate federal agencies before pursuing publication of this material. In November 2011, Yamaguchi received a phone call. The caller identified himself as a representative from the Department of Interior's Office of Science and Policy. The conversation, which Yamaguchi documented in notes dated November 18, 2011, lasted approximately 8 minutes. The caller asked about Yamaguchi's research at Crater Lake. He asked how many recordings existed. He asked whether Yamaguchi had shared the recordings with media or posted them online. Yamaguchi answered honestly. The recordings were with colleagues and had been submitted to journals but were not publicly available. The caller thanked him and ended the conversation. 3 days later, Yamaguchi received a letter from Oregon State University's Office of Research Integrity. The letter stated that questions had been raised about data collection protocols and institutional permissions related to his Crater Lake research. The letter requested that he cease field work and refrain from publishing results pending an internal review. The review concluded in February 2012 with no finding of misconduct, but by then Yamaguchi had moved on to other projects. He archived the Crater Lake recordings and never published his findings. The recordings still exist. Copies were made. Some researchers have them. Some have listened. None have published. In 2014, a science blogger named Angela Forrester wrote a post about unexplained acoustic phenomena in national parks. She mentioned Crater Lake briefly, citing anonymous sources who described structured underwater tones of unknown origin, recorded between 2009 and 2011. The post received modest attention, but no follow-up coverage. Crater Lake remains monitored. The USGS seismic stations remain active. Park rangers still patrol the rim. Tourists still photograph the impossible blue water. And somewhere in digital archives and personal collections, 17 recordings preserve 23 seconds of sound that something beneath the deepest lake in America was producing with mathematical precision, until the day new equipment began listening, and whatever was counting suddenly went silent. "23 people lost the same 40 minutes on the same afternoon, and none of them remember how." Stevens Pass sits at 4,061 feet in the Cascade Range of Washington State, where the Pacific Crest Trail crosses Highway 2 in a corridor that's been used by travelers since the Skykomish and Wenatchee peoples first established routes through these mountains. The pass was named for John Frank Stevens, who surveyed the region for the Great Northern Railway in 1893. By the mid-20th century, it had become a critical junction for both road and trail traffic, a place where wilderness and infrastructure intersected, where hikers could resupply before pushing north toward Canada or south toward the Columbia River. The Pacific Crest Trail through this section covers some of the most demanding terrain in Washington. The path climbs through old-growth forest, crosses exposed ridges with 1,000-foot drops, and navigates snowfields that persist into August. Cell phone coverage is non-existent. Radio communication is unreliable. Hikers are advised to carry emergency beacons and check in at ranger stations. The Forest Service maintains a small outpost at Stevens Pass specifically to monitor trail conditions and coordinate search and rescue operations when hikers go missing or get injured. On July 14, 1991, the weather was ideal. Clear skies. Temperature in the mid-70s. No wind to speak of. It was a Sunday, and the trail saw heavier traffic than usual, day hikers, through hikers heading north, and several groups doing weekend sections. By Forest Service estimates, somewhere between 40 and 50 people were on the trail within a 10-mile radius of Stevens Pass that afternoon. The incident began at approximately 2:17 p.m. A hiker named Douglas Rafferty, age 34, from Spokane, Washington, was hiking southbound. He'd started his day at Dishpan Gap, roughly 8 miles north of Stevens Pass, intending to reach the highway by late afternoon. His watch was a Casio digital model, battery-powered, purchased new 3 months earlier. At 2:17 p.m., according to his later testimony, he was crossing a ridge with clear views to the east when his watch display went blank. He tapped it. Nothing. He continued hiking, assuming the battery had failed. When he reached Stevens Pass at what he estimated was around 3:30 p.m., he checked the ranger station clock. It read 4:11 p.m. His watch had resumed working. The display showed 4:11 p.m. He'd lost over 40 minutes somewhere on the trail, but he had no memory of where or how. Rafferty mentioned the incident to the ranger on duty, a 28-year-old named Michael Brennan. Brennan noted it in the daily log, but wasn't particularly concerned. People misjudge time in the wilderness regularly, and watch malfunctions aren't uncommon. Then other hikers started arriving. At 4:23 p.m., two hikers, Jennifer Kowalski and Thomas DeLuca, both from Seattle, reached the ranger station. They asked Brennan what time it was. When he told them, Kowalski became visibly confused. She showed Brennan her wristwatch, a mechanical Seiko. It had stopped at 2:18 p.m. and had only recently started running again. DeLuca's watch showed the same thing. Both hikers described the same experience. They'd been hiking northbound, approaching the ridge crossing near Josephine Lake, when their watches stopped. They kept hiking. They didn't notice anything unusual, no dizziness, no disorientation, no lost time. But when they checked their watches again about 20 minutes later, by their perception, the watches had restarted and showed a time that was roughly 40 minutes ahead of what they expected. By 5 p.m., 11 more hikers had reported similar experiences. All had been on the trail between 1:30 and 2:30 p.m. All had experienced watch failures, digital and mechanical, various brands and models. All described a gap in time they couldn't account for. Some had been hiking alone, others had been in groups. None reported feeling strange or noticing anything unusual beyond the watch malfunction. Brennan contacted the Forest Service District Office in Skycomish. He described the reports and requested guidance. The district supervisor, a man named Gerald Paxton, told Brennan to document everything and have hikers fill out incident reports. Paxton also contacted the King County Sheriff's Office to inquire whether any search and rescue operations were needed. None were. All the hikers had made it off the trail safely. They'd just lost time. By 6 p.m., the count had reached 23 hikers. All reported watch failures between 2:15 and 2:20 p.m. All described a temporal gap ranging from 38 to 43 minutes. The affected area appeared to be concentrated around a 3-mile section of trail near Josephine Lake, where the PCT crosses an exposed ridge at roughly 5,200 feet elevation. Brennan collected the incident reports. He also made note of something else. His own watch, a battery-powered Timex he wore during his shift, had stopped at 2:17 p.m. and restarted at 2:58 p.m. He'd been inside the ranger station the entire time. He hadn't noticed when it stopped or when it started again. The Forest Service launched an investigation the following day. A team led by District Ranger Carolyn Mercer hiked the affected section of trail on July 15th. They found nothing unusual. No signs of seismic activity, no downed trees or rock slides. The trail was in good condition. The ridge crossing showed no evidence of recent disturbance. Mercer interviewed several of the affected hikers by phone over the following week. Their accounts were consistent. Most had been hiking during the 2:15 to 2:30 window. Most noticed their watches had stopped only after the fact, a few. Described brief moments of what they called zoning out, the feeling of covering distance without actively remembering the steps taken, but attributed this to the meditative nature of long-distance hiking. One hiker, a through hiker named Patricia Osgood from Vermont, described something slightly different. She'd been hiking alone, northbound, and remembered reaching the ridge near Josephine Lake. She remembered starting across. She remembered the view, clear visibility for miles, Mount Rainier visible to the south. Then her next memory was of being past the ridge, maybe half a mile farther north, without any recollection of walking that distance. Her watch had stopped. When she checked it, confused by the gap in her memory, it restarted. The time displayed was 42 minutes later than she expected. The Forest Service consulted with experts at the University of Washington. Dr. Raymond Gutierrez, a geophysicist, reviewed the reports and suggested possible explanations. Localized magnetic anomalies that could affect watch mechanisms, unusual atmospheric conditions, or even mass suggestibility. None of these explanations fit perfectly. Magnetic anomalies don't stop mechanical and digital watches simultaneously. The weather had been stable, and 23 people experiencing identical watch failures and time loss, independently and without prior communication, stretched the limits of psychological explanations. Dr. Ellen Vasquez, a psychologist specializing in perception and memory, offered another possibility: temporal disorientation caused by environmental factors. She noted that certain combinations of altitude, dehydration, and visual monotony could create brief dissociative states, but even she acknowledged the difficulty in explaining why watches would malfunction during these states. The most puzzling detail emerged when Brennan reviewed radio logs from July 14th. The Forest Service maintained several repeater stations in the Cascades to extend radio range for ranger communication. The repeater nearest to Stevens Pass recorded a gap in transmissions between 2:17 and 2:58 p.m., 41 minutes. During that window, every attempted radio contact failed. No distress calls came through. No routine check-ins were logged. The radios weren't malfunctioning, they simply transmitted nothing, as if all ranger units in the region had gone silent simultaneously. Brennan obtained copies of CB radio logs from a trucker who regularly traveled Highway 2. The trucker, whose name was listed in reports as William Strand, kept detailed records of his radio communications. On July 14th, his log showed a gap. No CB traffic between 2:16 and 2:59 p.m. along the stretch of Highway 2 that paralleled the trail near Stevens Pass. Strand noted in his log that he'd tried to make contact several times during that period and received only static. The Forest Service submitted its findings to the National Weather Service and the National Oceanic and Atmospheric Administration in August 1991. The report described the incident as unexplained temporal and communication anomaly possibly related to atmospheric conditions. It requested analysis of any solar activity, atmospheric disturbances, or geomagnetic events that might have occurred on July 14th. The NOAA response, dated September 9, 1991, stated that solar activity on July 14th had been minimal. There were no recorded geomagnetic storms. Atmospheric conditions in the region had been stable. The response concluded that no atmospheric or space weather phenomena consistent with the described effects were observed on the date in question. The official Forest Service incident report, filed in October 1991, listed the cause as atmospheric interference of unknown origin. The report recommended continued monitoring, but noted that no similar incidents had been reported before or since. The case was closed pending any future occurrences. No future occurrences were ever documented. The Pacific Crest Trail continues to cross the ridge near Josephine Lake. Thousands of hikers pass through every year. Watches function normally. Radios work. Time proceeds as expected. But the hikers who were there on July 14, 1991, still can't explain what happened. Some have tried to reconstruct those missing 40 minutes by comparing their memories, where they were, what they saw, what came next. The memories don't align. Some remember trees. Some remember open sky. Some remember nothing at all, just the discontinuity between one step and the next, between one moment and another moment that should have been 40 minutes later, but felt like no time at all. And in the Forest Service Archive in Skycommish, there's a log book page from July 14, 1991. Brennan's handwriting documents the day's events, weather conditions, visitor counts, incident reports. At the bottom of the page, written in blue pen, is a single line, radio silence 1417 to 1458 hours, no explanation. All units unresponsive. The timestamp matches the watches, 41 minutes, 23 people, one ridge. And a silence that no atmospheric report could explain, stretching across radio frequencies and human memory, like something had paused the world for just long enough to go unnoticed, until everyone compared their clocks and realized that the same piece of the afternoon had gone missing for all of them at once. Some caves in the Cascades breathe, but only one breathes back. Mount Rainier dominates the skyline of western Washington, a 14,410-foot stratovolcano that last erupted in the mid-19th century, but remains classified as one of the most dangerous volcanoes in the Cascade Range. The mountain is wrapped in 26 named glaciers and honeycombed with ice caves, steam vents, and fumaroles, places where the volcano's heat meets ice and rock to create temporary passages that shift with the seasons. Paradise Valley, on the mountain's southern flank, sits at 5,400 feet and receives an average of 53 feet of snow annually, making it one of the snowiest places on Earth with reliable measurements. The Cowlitz and Yakima peoples knew the mountain as Tahoma or Tacoma, names that carried warnings. They rarely climbed above the tree line. Stories spoke of spirits in the high places, of sounds that came from beneath the snow, of passages that led into the mountain and didn't always lead back out. When white settlers arrived in the 19th century, they dismissed these warnings as superstition. But mountaineers who attempted early ascents reported strange phenomena. Unexplained warmth in certain areas, sounds like breathing from snow-covered crevasses, and a persistent feeling of being followed on solo climbs. The cave was first documented in July 1974 by a climbing party from the Mazamas, a Portland-based mountaineering organization. The group, led by an experienced climber named Howard Lindstrom, was exploring the western edge of Paradise Valley when they discovered an opening in a rocky outcrop partially obscured by summer snowmelt. The entrance was roughly 4 feet wide and 5 feet tall, angled downward into darkness. What caught their attention was the air, warm, noticeably warmer than the surrounding environment, and moving in rhythmic pulses. Lindstrom described the phenomenon in his expedition report dated August 2, 1974. He noted that the air movement wasn't constant, but occurred in regular intervals, approximately 40 to 50 seconds between each exhale. The temperature differential was significant, perhaps 20 degrees warmer than the ambient mountain air. He and two others, Patricia Vidal and Robert Tanaka, entered the cave with headlamps and basic equipment. The passage descended at a shallow angle for roughly 30 feet before opening into a larger chamber. The warm air pulses were stronger inside, accompanied by a low sound that Lindstrom described as similar to wind through a narrow gap, but too regular to be natural air movement. They explored for approximately 45 minutes, mapping roughly 200 feet of passage before equipment concerns prompted them to exit. Lindstrom's compass had begun spinning erratically. Vidal's flashlight dimmed despite fresh batteries. All three reported mild headaches that dissipated once. They returned to the surface. They marked the location on their maps and reported the cave to Mount Rainier National Park upon their return. The Park Service dispatched a ranger named Douglas Kellerman to investigate in September 1974. Kellerman was a geologist by training and had worked at Rainier for 6 years. He visited the site with another ranger, Sarah Whitfield, and confirmed the cave's existence and the unusual air movement. His report, filed September 23, 1974, described the phenomenon as likely related to volcanic thermal activity, possibly a fumarole or steam vent with restricted airflow creating pulsed release patterns. He recommended additional geological study, but noted the cave's remote location and seasonal accessibility made detailed investigation challenging. No formal study was conducted until 1982, when a team from the University of Washington's Department of Earth and Space Sciences obtained a permit to explore the cave system. The team leader was Dr. Margaret Kowalski, a volcanologist specializing in geothermal systems. She brought 2 graduate students, James Okafor and Linda Severance, and an array of monitoring equipment: thermometers, barometers, seismometers, and gas detectors. They spent 3 days at the site in August 1982. Their findings, documented in a preliminary report dated September 15, 1982, confirmed the rhythmic air movement. Kowalski measured the intervals precisely, 47 seconds between each pulse, with less than 1 second of variation. The air temperature during pulses reached 78 degrees Fahrenheit, significantly warmer than the cave's ambient temperature of 42 degrees. Gas analysis showed normal atmospheric composition, no volcanic gases, no carbon dioxide buildup, nothing to suggest active fumarole activity. What disturbed Kowalski was the consistency. Geothermal features don't pulse with that kind of regularity. Wind patterns are chaotic. Even the most regular fumaroles show variation. This didn't. Over 72 hours of continuous monitoring, the 47-second interval never wavered by more than 0.8 seconds. Kowalski's report also mentioned something else. On their second night camped near the cave entrance, all 3 researchers reported the same dream. Walking through the cave passage, descending deeper than they'd actually explored, aware of something behind them in the darkness, something that matched their pace and their breathing. Okafor described waking at 3 a.m. and hearing the pulse of warm air from the cave entrance, but in the half-sleep state, it had sounded like breathing, slow, deliberate, and too large to be human. A second team investigated in July 1989. Dr. Raymond Gutierrez, a geophysicist from Oregon State University, led a group of 4 researchers. They brought more sophisticated equipment, including ground penetrating radar to map the cave system's extent. The radar results were inconclusive. The volcanic rock's composition created too much interference. They confirmed the 47-second pulse pattern and recorded it continuously for 5 days. The pattern held during the day. It held at night. It never stopped. Gutierrez's team also experienced the dreams. All 4 researchers, sleeping in separate tents, reported variations of the same experience: walking into the cave, descending, hearing breathing that wasn't their own. One researcher, a graduate student named Michael Brennan, described waking with the distinct feeling that something had been standing outside his tent, exhaling in time with the cave's pulse. The team noticed something else. The pulse stopped during the new moon. On July 24, 1989, the night of the new moon, the rhythmic air movement ceased entirely for approximately 8 hours. The cave was silent. No warm air, no pulses. At dawn, the pattern resumed exactly as before: 47 seconds, no variation. Gutierrez's final report, submitted in October 1989, stated that no conventional geological process adequately explains the observed phenomena. He recommended sealing the cave for safety reasons, citing equipment malfunctions and psychological stress reported by multiple research teams. The recommendation wasn't immediately acted upon. In June 1993, a spelunking group from Seattle obtained a backcountry permit and explored the cave without formal authorization. The group consisted of 6 experienced cavers. They descended farther than previous teams, mapping approximately 500 feet of passage. 4 of the 6 reported equipment failures. Lights, compasses, and GPS units all malfunctioned simultaneously at roughly 300 feet depth. Two members of the group, Amanda Kowalczyk and David Pierce, refused to continue after both described hearing what they called matched breathing, the sensation that something in the darkness ahead was inhaling and exhaling in perfect sync with their own breath. The group exited without incident, but filed a report with the Park Service describing the cave as psychologically disturbing in ways that exceed normal underground disorientation. The Park Service responded by restricting access to the area, requiring special permits for any cave exploration near Paradise Valley. The final investigation occurred in May 1998. A three-person team from the USGS Cascades Volcano Observatory was conducting routine geothermal monitoring on Mount Rainier. Dr. Ellen Vasquez, the team leader, decided to visit the cave after reviewing previous reports. Her team spent 2 days on site. They confirmed everything: the 47-second pulse, the temperature differential, the equipment malfunctions, and the dreams. Vasquez's report, dated June 8, 1998, included a recommendation that shocked the park. Service, immediate closure and sealing of the cave entrance. She cited unexplained phenomena that may pose risk to visitor safety and mental well-being. She also included a personal note, unusual for an official USGS document. She wrote, "On our final night, all three team members experienced identical dreams of descending into the cave system while something followed at a precise distance, matching our movements and our breathing. Upon waking, we could hear the pulse from the cave entrance, but the rhythm had changed. It was no longer 47 seconds. It was matching our resting respiratory rate, approximately 14 breaths per minute, or roughly 4.3 seconds per breath. This continued until we broke camp and moved a quarter mile from the site, at which point the original 47-second pattern resumed." The Park Service sealed the cave entrance in August 1998, using concrete and rebar. The official justification cited geological instability and visitor safety. No press release was issued. The closure wasn't announced publicly. The cave simply disappeared from Park Service maps and trail guides. But hikers still report it. Every few years, someone posts online about finding warm air pulses near Paradise Valley, about a concealed entrance that seems to breathe, about dreams of descending into darkness while something matches their pace. The Park Service responds to these reports with standard safety warnings about unauthorized cave exploration and volcanic hazards. The sealing itself has become part of the mystery. In 2006, a backpacker photographed the sealed entrance and posted the image to a hiking forum. The concrete plug showed no signs of weathering despite 8 years of exposure to Rainier's extreme conditions. More unsettling, several commenters claimed to have visited the same location and found no seal, only an open entrance with warm air pulsing out in regular intervals. The Park Service declined to comment on these reports. When pressed by a journalist from the Tacoma News-Tribune in 2009, a spokesperson stated only that the cave in question was sealed for safety reasons in 1998 and remains closed to public access. No explanation was given for why 3 separate geological teams experienced the same dream. No explanation was given for the 47-second interval or why it stops during new moons. No explanation was given for why experienced researchers with decades of fieldwork collectively recommended sealing a cave because of its psychological effects. And no explanation was given for what Dr. Vasquez heard on that final night, the moment when something beneath Mount Rainier stopped breathing at its own rhythm and started breathing at hers, as if it had been waiting all along for someone to notice, to listen, and to finally understand that the mountain wasn't just exhaling warm air through a crack in the rock. It was responding. Some buildings exist only on paper, but they keep appearing in the same place. Packwood sits in the southern Cascades of Washington State, a town of fewer than 300 permanent residents that serves as a gateway to the Gifford-Pinchot National Forest. The surrounding wilderness covers over 1.3 million acres of old-growth forest, volcanic peaks, and river valleys that have remained largely unchanged since the Yakima and Cowlitz peoples first inhabited the region. When the Forest Service began systematic surveys of the area in the early 20th century, they encountered terrain so dense and remote that accurate mapping required years of fieldwork. Surveyors worked with compasses, chain measurements, and plane tables documenting every creek, ridge, and man-made structure they encountered. The region had a history of isolated homesteads. From the 1880s through the 1920s, settlers claimed land under the Homestead Act, clearing small parcels and building cabins in valleys that could take days to reach on foot. Many of these homesteads failed. The winters were brutal. The isolation was absolute. By the 1930s, dozens of abandoned cabins dotted the forest, slowly being reclaimed by Douglas fir and western hemlock. The Forest Service documented these structures as historical features, marking them on maps with standard symbols. A small square with a specific notation indicating abandoned dwelling or homestead ruins. In July 1936, a Forest Service surveying crew led by a man named Walter Kosinski was mapping a drainage basin approximately 8 miles northeast of Packwood. The area was designated as Section 18, Township 13 North, Range 9 East. Kosinski's crew consisted of 3 men, himself, a chainman named Bernard Fitzgerald, and a rodman named Thomas Whitmore. They were creating what the Forest Service called a type map, a detailed survey showing topography, vegetation, water sources, and any human structures. On July 23, 1936, the crew documented a homestead at coordinates that placed it roughly half a mile west of Butter Creek, a seasonal tributary that feeds into the Cowlitz River. Kosinski's field notes, preserved in Forest Service archives, describe the structure as a single-story log dwelling, approximately 20 by 24 feet, with collapsed roof and partial wall deterioration. He noted the presence of a stone chimney, a small cleared area suggesting a former garden plot, and evidence of a root cellar. The crew marked the location on their survey map using standard notation and continued their work. The survey was completed in September 1936. The maps were submitted to the Forest Service Regional Office in Portland and approved for publication in March 1937. These maps were used for fire management, timber sales, and recreational planning. The homestead appeared on them as a small square, with the notation "Abandoned Dwelling near Butter Creek." In May 1937, a different Forest Service crew was conducting a timber cruise, an assessment of harvestable trees in the same area. The crew leader, a forester named Margaret Sullivan, used Kosinski's map to navigate. When she reached the location of the documented homestead, she found nothing. No logs, no chimney stones, no clearing. Just dense forest with trees that appeared, based on their size and the thickness of the duff layer beneath them, to be at least 80 to 100 years old. Virgin forest, undisturbed. Sullivan reported the discrepancy to the district ranger, a man named Harold Jennings. Jennings reviewed Kosinski's original field notes and compared them to Sullivan's report. The coordinates matched. The description of the surrounding terrain matched. But the homestead was gone. Jennings contacted Kosinski, who had been reassigned to another district. Kosinski insisted his survey was accurate. He described the homestead in detail, the notched log construction, the fieldstone chimney, the remnants of a wooden door frame. He said his crew had spent 20 minutes at the site, taking measurements and making notes. Fitzgerald and Whitmore, when contacted separately, confirmed Kosinski's account. Jennings filed a report in June 1937 describing the situation as a surveying error, likely due to misidentification of location or misreading of coordinates. The homestead was removed from subsequent map editions. The incident was noted in district records and forgotten. 21 years later, in April 1958, the Forest Service began a comprehensive remapping project using updated surveying techniques and aerial photography. A surveyor named David Tanaka was assigned to Section 18, Township 13 North, Range 9 East, the same area Kosinski had mapped in 1936. Tanaka's work involved cross-referencing aerial photos with ground surveys to ensure accuracy. In his field report dated May 14, 1958, Tanaka documented a homestead at coordinates that matched, within 50 feet, the location Kosinski had recorded in 1936. Tanaka's description was nearly identical: single-story log structure, collapsed roof, stone chimney, evidence of cleared land. He photographed the site using a Kodak Brownie camera. The photographs were submitted with his report. When the photographs were developed, they showed forest. Dense, undisturbed forest. No homestead, no clearing, no chimney. Tanaka was baffled. He insisted he'd been at the site. He described climbing over fallen logs, examining the remains of the chimney, noting the squared logs that indicated deliberate construction. His field notes were detailed and consistent, but the photographs showed nothing. A supervisor named Patricia Morales accompanied Tanaka back to the site in June 1958. They used Tanaka's coordinates and his field notes to navigate. When they arrived at the location, Morales saw what Tanaka had described in his report: forest. Old-growth forest with no signs of human activity. Tanaka stood at the site, confused and insistent. He pointed to where he said the chimney had been, where the walls had stood. Morales saw nothing but trees. The incident was recorded as observer error, possibly due to fatigue or misidentification of location. Tanaka was reassigned. The homestead did not appear on the 1958 maps. In August 1979, a geology student from the University of Washington named Rebecca Kowalski was conducting research on glacial deposits in the Packwood area. She was using USGS topographic maps for navigation. While hiking through Section 18, she discovered what she described in her field journal as remnants of an old homestead: logs, stone chimney base, clearing. She marked the location on her map and took several photographs using a Nikon 35mm camera. When she returned to campus and developed the film, the photographs showed forest. She returned to the site 3 days later with a classmate, Michael Brennan. They used her GPS unit, a relatively new technology in 1979, to navigate to the exact coordinates she'd recorded. They found forest. Kowalski insisted she'd seen the homestead. Brennan saw nothing. They spent 2 hours searching the area. Kowalski eventually concluded she'd been mistaken about the location, though her journal entries from the original visit were detailed and confident. The most recent occurrence was in July 2003. A Forest Service employee named James Rafferty was conducting a routine trail maintenance assessment near Butter Creek. He was using a handheld GPS unit and digital camera. His report, filed July 18, 2003, documented abandoned homestead structure, significant deterioration, stone chimney intact, at coordinates matching historical survey records from 1936. Rafferty's digital photographs attached to the report showed forest. A supervisor named Ellen Vasquez reviewed the report and contacted Rafferty. He stood by his observations. He described spending 15 minutes at the site, noting the construction details, estimating the age of the structure. Vasquez asked to see the photos he'd taken. Rafferty opened the files on his computer. Forest, just trees and undergrowth. Vasquez and another ranger, Douglas Kellerman, visited the site with Rafferty in August 2003. All three used the GPS coordinates from Rafferty's report. They arrived at a location that matched the terrain description perfectly, near Butter Creek, on a slight rise with good drainage and southern exposure, exactly where a homesteader would build. They found forest, old trees, thick understory, no signs of clearing, no stone, no logs beyond the natural deadfall common in old-growth forests. Rafferty was disturbed by the discrepancy. Vasquez suggested he'd experienced a vivid daydream or had been suffering from mild dehydration. Rafferty disagreed but had no explanation. The incident was filed as observation error and closed. In 2009, a researcher named Angela Torres at Portland State University was studying historical land use patterns in the Gifford-Pinchot National Forest. She was reviewing archival Forest Service maps when she noticed something unusual: a homestead appearing in the same location across 4 separate map editions: 1936, 1958, 1979, and 2003, each time followed by removal in the subsequent edition with notation of surveying error or observer error. Torres contacted the Forest Service to inquire about the pattern. She was told that the repeated errors were coincidental, likely due to poor training or confusion about coordinate systems across different surveying eras. When she asked to see the original field notes from all 4 surveys, she was informed that some records had been lost, damaged, or transferred to regional archives that required formal research requests to access. Torres filed the requests. The 1936 notes were available and confirmed Kosinski's detailed observations. The 1958 notes were missing from the archived materials. The 1979 observations came from a private citizen, not an official survey, and were not formally archived. The 2003 report was available but had been marked inconclusive with a supervisor's note stating observer reliability questioned. Torres attempted to contact the surveyors. Kosinski had died in 1974. Tanaka was retired and declined to be interviewed. Kowalski, the geology student, responded via email, but said she no longer remembered the incident clearly and had concluded long ago that she'd been mistaken. Rafferty agreed to speak with Torres by phone. He confirmed his observations from 2003 and said he'd never found a satisfactory explanation for why his photographs showed something different from what he'd seen. Torres published a paper in 2011 titled Cartographic Anomalies and Observer Reliability in Remote Wilderness Surveys. The paper discussed the Packwood homestead as a case study in how surveying errors could compound across decades when original errors weren't properly documented. The paper was accepted by a small academic journal focused on forestry history and attracted minimal attention. The homestead has not appeared on maps since 2003. The Forest Service continues to maintain trails and conduct surveys in the area. Section 18, Township 13. North Range 9. East remains dense, remote, and difficult to access. Hikers occasionally pass through. None have reported seeing abandoned structures. But the pattern remains. 4 surveys, spanning 67 years, conducted by trained professionals using different technologies: compass and chain, aerial photography, GPS. 4 times, the same location was documented as containing an abandoned homestead. 4 times, verification found nothing. And 4 times, the observers insisted they'd seen it: logs, stone, clearing, the unmistakable signs of human presence in a place where the forest now stands as if it had never been disturbed. The coordinates remain in the archives. The field notes remain, at least the ones that haven't been lost, and somewhere in the dense forest northeast of Packwood, there's a place where 4 different people, across 4 different decades, stood and saw something that the cameras, the photographs, and every subsequent visitor says was never there. A homestead that appears, is documented, and vanishes, leaving only the question of what they saw and why it only exists in the moment of observation, disappearing the instant anyone tries to prove it was real. Fog doesn't have corners except the one that settled over Marble Mount in October 2006. Marble Mount is a census-designated place in Skagit County, Washington, population roughly 300, situated where the Cascade River meets the Skagit River in a valley hemmed by mountains that rise 6,000 feet on either side. The town exists primarily as a waypoint, the last supply stop before the North Cascades Highway climbs into true wilderness. Loggers built it in the early 20th century. When the timber industry declined, Marble Mount survived on tourism and the handful of seasonal workers who staffed the nearby ranger stations. The weather here follows predictable patterns. Heavy rain from October through May, occasional fog in the river valleys, snow at higher elevations. Meteorological anomalies are rare. The weather is consistent, documented, and unremarkable. The region has a history older than the town. The Upper Skagit and Sauk-Suiattle peoples knew these valleys as places where the physical and spiritual worlds overlapped. Stories spoke of boundaries that shifted, of mist that came from nowhere and divided the world into pieces. When settlers arrived in the late 1800s, they dismissed these accounts as mythology, though early logging crews occasionally reported strange fog formations that moved uphill or gathered in shapes that seemed deliberate rather than natural. On October 12, 2006, at approximately 4:37 a.m., a fog bank appeared over Marble Mount. The first person to notice was a truck driver named Gerald Strand, who was hauling timber from a yard north of town. He'd been driving State Route 20 when the fog appeared suddenly in his headlights, not gradually thickening as fog typically does, but materializing as a wall. Strand described it later as like driving into a painted backdrop. He slowed his truck and noted the time on his dashboard clock. The fog was dense, visibility reduced to perhaps 10 feet, but what struck him as unusual was its edge. He'd passed through the boundary between clear air and fog in a single instant, as if crossing a threshold. Strand continued driving slowly. After roughly a quarter mile, he emerged from the fog just as abruptly. Clear air. Stars visible overhead. He looked in his rearview mirror and saw the fog bank behind him, a solid mass with a defined edge that appeared to run perpendicular to the road. He documented the observation in his logbook and continued his route. By 6 a.m., other residents began noticing the fog. A diner owner named Margaret Kowalski opened her restaurant and found the town blanketed in dense, gray mist. She stepped outside and walked to the edge of the fog, approximately 50 yards from her building, and found a boundary so sharp she could stand with one hand in fog and one in clear air. The temperature was the same on both sides. No wind, no moisture condensing on her skin despite the apparent density of the fog. By 7 a.m., roughly 40 residents had gathered at the fog's edge, which formed an irregular but geometrically precise perimeter around the town. The fog didn't thin at its boundary. It ended. The shape was roughly rectangular, with corners that formed what several witnesses described as 90-degree angles. The fog covered approximately 2 square miles, encompassing most of Marble Mount's developed area and portions of the surrounding forest. A deputy sheriff named Thomas Rafferty arrived from Concrete, a town 15 miles west, at approximately 7:45 a.m. He'd received calls about the fog from concerned residents. Rafferty documented the phenomenon in his incident report, filed October 13, 2006. He noted the fog's unusual boundaries, the lack of wind, and the absence of moisture. He walked the perimeter, which he estimated took roughly 40 minutes. The fog remained stationary. Its edges remained sharp. At one point, Rafferty placed a marker at the boundary and watched for 15 minutes. The fog didn't advance or recede. By 9 a.m., word had spread to regional authorities. A meteorologist from the National Weather Service office in Seattle, Dr. Raymond Gutierrez, received a call from the Skagit County Emergency Management Office. Gutierrez consulted weather station data and found no atmospheric conditions consistent with fog formation. The temperature was 52 degrees Fahrenheit. Relative humidity was 63%, well below the saturation point required for fog. Barometric pressure was stable, no temperature inversion, no moisture advection, no meteorological mechanism that would produce fog. Gutierrez drove to Marble Mount, arriving at approximately 11:30 a.m. He brought handheld instruments, a hygrometer, thermometer, and an anemometer. He conducted measurements at the fog boundary and inside the fog bank. The results contradicted visual observation. The hygrometer showed no increase in moisture content inside the fog compared to outside. The temperature was identical. There was no wind on either side of the boundary. Gutierrez described his observations in a preliminary report dated October 14, 2006. He wrote, "Visual appearance suggests dense fog with visibility of approximately 10 feet. Instrumental measurements indicate no fog is present. Moisture content, temperature, and pressure are consistent with clear air conditions. The phenomenon is visible but not measurable." A second meteorologist, Dr. Ellen Vasquez from the University of Washington, arrived on October 13th with additional equipment, including a ceilometer to measure cloud base height and a visibility sensor. Her instruments confirmed Gutierrez's findings. The fog appeared to exist visually, but not physically. Light scattered within the fog as expected. Headlights and flashlights showed the characteristic glow and limited penetration of fog conditions, but no moisture was present. Vasquez collected air samples from inside and outside the fog boundary. Laboratory analysis showed identical composition. Normal atmospheric gases, no particulates, no unusual aerosols. Residents described the experience of being inside the fog as disorienting but not dangerous. Visibility was severely limited. Sounds were muffled, but there was no wetness, no chill, none of the sensory markers typically associated with fog. Several people reported feeling watched, though they attributed this to the psychological effect of limited visibility in familiar surroundings. The fog remained stationary for 48 hours. Its boundaries didn't shift. Its density didn't change. Weather patterns during this period included light winds from the west, consistent with seasonal norms. The fog didn't respond to these winds. It remained fixed in place, geometrically precise, visible but physically unmeasurable. On October 14th, at approximately 4:45 p.m., a photographer from the Seattle Times, a woman named Patricia Moreno, arrived to document the phenomenon. She took several photographs from outside the fog boundary, showing the sharp edge and the density within. She also entered the fog with a camera and took photographs from inside. The images showed reduced visibility and the gray diffusion of light characteristic of fog. But when she reviewed the images later, something was wrong. The photographs taken from outside the fog showed clear air, no fog bank, just the town and surrounding forest in normal October conditions. The photographs taken from inside showed the same thing. Clear visibility, no fog. Only her visual memory and the testimony of dozens of witnesses confirmed that the fog had been present. By October 14th, the phenomenon had attracted attention from atmospheric scientists across the region. Dr. Leonard Yamaguchi, a physicist specializing in optical phenomena, visited the site and proposed that the fog might be an optical illusion, a form of atmospheric refraction creating the appearance of fog where none existed. But this theory didn't explain why the illusion was localized, why it had precise geometric boundaries, or why it affected multiple observers simultaneously from different positions. Gutierrez and Vasquez submitted their findings to the National Oceanic and Atmospheric Administration on October 16, 2006. Both reports described the phenomenon as visually apparent fog with no corresponding meteorological or physical measurements. Gutierrez recommended further study. Vasquez noted that the event represented an unexplained atmospheric optical phenomenon requiring investigation by specialists in atmospheric optics and perception. 3 days later, on October 19th, Gutierrez received a phone call. The caller identified himself as representing NOAA's Office of Science and Technology. The conversation, which Gutierrez documented in notes dated October 20th, lasted approximately 7 minutes. The caller asked about the instruments used in the Marble Mount observations. He asked about calibration procedures. He suggested that the apparent fog and the instrument readings might both be correct if the instruments had been incorrectly calibrated. Gutierrez explained that multiple instruments from different sources had been used, all showing consistent results. The caller thanked him and ended the conversation. Vasquez received a similar call on October 20th. The caller, possibly the same person, though Vasquez couldn't be certain, suggested that her equipment might have malfunctioned due to electromagnetic interference from power lines in the area. Vasquez noted that her instruments were shielded and that no power lines existed near her measurement locations. The caller suggested she review her calibration protocols and ended the call. A third meteorologist, Dr. Priya Mehta from Oregon State University, had independently analyzed satellite imagery from October 12th through 14th. She found no cloud cover over Marble Mount during the 48-hour period. Satellite thermal imaging showed no temperature anomalies. Visible light imagery showed normal ground conditions. She submitted her analysis to the American Meteorological Society Journal in November 2006. The submission was rejected in December with a brief note stating that the described phenomenon lacks sufficient documentation and peer-reviewed support for publication. Mehta received a phone call in January 2007. The caller identified himself as being from the Department of Commerce, which oversees NOAA. He asked about her satellite analysis and suggested that cloud cover at low altitude might not be visible in the satellite imagery she'd reviewed. Mehta explained that her analysis had included multiple wavelengths and that even low-altitude fog would produce measurable signals. The caller thanked her and said her diligence was noted. None of the 3 meteorologists published their findings. Gutierrez moved to a position in Alaska in 2008. Vasquez continued her academic work but declined to discuss the Marble Mount incident in subsequent interviews. Mehta archived her analysis and didn't pursue further investigation. The fog dissipated on October 14, 2006, at approximately 4:30 a.m., exactly 48 hours after it had appeared. Residents described the dispersal as instantaneous. One moment the fog was present, dense and geometrically bounded. The next moment, it was gone. Clear air, normal visibility. No gradual thinning, no wind-driven dispersal, just an immediate transition from fog to clarity. Deputy Rafferty filed a supplemental report on October 15th, noting the fog's disappearance and the absence of any physical evidence that it had existed. No moisture remained on surfaces. No temperature change was recorded. The event left no measurable trace beyond the testimony of witnesses and the documented observations of 3 meteorologists whose instruments had measured nothing. In 2009, a graduate student in atmospheric sciences named Angela Torres at the University of Washington came across references to the Marble Mount incident while researching historical weather anomalies in the Pacific Northwest. She contacted residents and obtained copies of witness statements. She also attempted to obtain the meteorological reports from Gutierrez, Vasquez, and Mehta. Gutierrez didn't respond to her inquiries. Vasquez replied with a brief email stating she no longer had documentation from that period. Mehta said her analysis had been inconclusive and declined to share her data. Torres eventually located Rafferty, who had retired from the sheriff's office. He confirmed his observations and provided copies of his incident reports. He also mentioned something he hadn't included in the official documentation. During the 48 hours the fog was present, he'd walked the perimeter multiple times. Each time, he had the distinct impression that the fog was not dispersing naturally, but was being held in place, maintained by something he couldn't identify or measure. He said the corners were too perfect, the edges too sharp, and the persistence too exact. 48 hours to the minute. He'd never seen weather behave with that kind of precision. The town of Marble Mount continues its existence as a waypoint on the edge of wilderness. Fog forms in the valley during autumn and winter, as it always has. The fog is normal, moisture-laden, temperature-dependent, wind-responsive. It forms gradually, drifts with air currents, and dissipates naturally, but some residents still remember the fog from October 2006. They remember its edges. They remember standing with one hand in gray and one hand in clear air, feeling no difference in temperature or moisture, only the visual boundary between two states that shouldn't have been separate. And they remember the silence from the Weather Service, the phone calls to the meteorologists, and the way the fog left no evidence of its existence beyond the shared memory of 48 hours when something invisible held the town inside geometric boundaries that weather doesn't make and instruments couldn't measure. Some structures lose more than just their blueprints. Deception Pass Bridge connects Whidbey Island to Fidalgo Island in Washington State, spanning a tidal channel where Pacific currents create some of the most turbulent waters in the region. The pass earned its name in 1792 when British explorer George Vancouver initially mistook Whidbey Island for a peninsula, only to discover the narrow waterway that separated it from the mainland. The waters below run fast and cold, with tidal exchanges creating whirlpools visible from the bridge deck. Indigenous Samish and Swinomish peoples avoided crossing at certain times, believing the currents marked a threshold between worlds, a place where distances couldn't be trusted, and travelers occasionally emerged on the far shore with no memory of the crossing. The bridge was completed in 1935, a Depression-era public works project employing Civilian Conservation Corps workers and funded by federal infrastructure programs. The design consisted of two steel cantilever spans connected by an anchor block on Pass Island, a rocky outcrop in the middle of the channel. At the time of its completion, it represented significant engineering achievement. 180 feet above the water at high tide, designed to withstand the region's notorious winds and seismic activity. The project was documented extensively, with engineers maintaining detailed construction logs, material inventories, and surveying records. These documents were standard practice for major infrastructure projects and were filed with both state and federal agencies for future maintenance and safety assessments. The discrepancy emerged during routine documentation in the summer of 1934, though it wouldn't be recognized as such for another year. A surveying team led by Chief Engineer Walter Lindstrom was conducting final measurements before the bridge's official opening. The team consisted of Lindstrom, Assistant Engineer Margaret Sullivan, and 3 surveying technicians, Thomas Oakes, Bernard Kowalski, and Dorothy Whitfield. They were using standard surveying equipment, transit levels, steel chains, and theodolites to verify that the constructed bridge matched the approved design specifications. On August 7, 1934, Lindstrom's team recorded the main span length as 987 feet, measured from the center of one anchorage to the center of the opposite anchorage. This measurement was taken 3 times using different equipment and different crew members to ensure accuracy. All 3 measurements confirmed 987 feet. The number was recorded in the official construction log signed by Lindstrom and submitted to the Washington State Highway Department on August 15, 1934. The bridge opened to traffic on July 21, 1935. A ceremony attended by state officials and federal representatives marked the occasion. Photographs from the event show the completed structure, flags flying from the towers, crowds gathered at both approaches. Nothing in the ceremony or the subsequent weeks suggested any irregularity. In September 1935, a different surveying team arrived to conduct post-construction verification, standard practice to ensure no settling or structural movement had occurred during the first months of use. This team was led by an Army Corps of Engineers surveyor named Captain Robert Tanaka. His crew included military engineers and civilian contractors working under federal oversight. Their purpose was to verify the bridge's specifications against the original design documents and ensure structural integrity. Tanaka's team measured the main span at 976 feet. The measurement was repeated 5 times. Every measurement produced the same result, 976 feet, 11 feet shorter than Lindstrom's recorded measurement from the previous year. Tanaka documented the discrepancy in a report filed September 30, 1935. He noted that the difference exceeded acceptable tolerances for surveying error and requested access to the original construction logs and blueprints to determine whether a documentation error had occurred. His report was classified restricted and forwarded to the War Department in Washington, D.C. What happened next remained unclear for decades. The original blueprints, stored at the State Highway Department's office in Olympia, were requested by federal authorities in October 1935. According to records obtained through Freedom of Information Act requests in the 1990s, the blueprints were transferred to the custody of the Army Corps of Engineers on October 18, 1935, under provisions related to critical infrastructure assessment. The blueprints were never returned. Lindstrom was contacted by federal officials in November 1935. He was asked to provide copies of his surveying logs and to report for an interview at the Army Corps office in Seattle. According to a letter Lindstrom wrote to his sister, dated November 23, 1935, and preserved in family archives, he was questioned about his surveying methods, his equipment calibration, and the possibility of recording errors. Lindstrom insisted his measurements were accurate. He provided his original field notes, which clearly showed 987 feet, recorded multiple times with consistent results. The Army Corps retained Lindstrom's field notes. He was given a receipt, but no copies. He was also asked to sign a document, which he described in his letter as a security acknowledgement, agreeing not to discuss the matter publicly. Lindstrom found this unusual for what he believed was a simple measurement discrepancy, but he complied. Sullivan, the assistant engineer, was interviewed separately in December 1935. She confirmed Lindstrom's measurements and stated that the surveying had been conducted according to standard procedures. Her interview notes, partially declassified in 2003, include a line stating, "Subject insists measurements were verified 3 times. Subject cannot explain Army Corps' findings of different length." The other 3 surveyors, Oakes, Kowalski, and Whitfield, were also interviewed. All confirmed the 987-foot measurement. All signed security acknowledgments. None of them publicly discussed the discrepancy again. In March 1936, the Army Corps of Engineers issued a report declaring that the correct span measurement was 976 feet and that the 1934 measurements had been affected by calibration error in surveying equipment. The report stated that new measurements using military-grade instruments had confirmed the 976-foot span. The report was marked "Official Use Only" and distributed to relevant state and federal agencies. It became the official record. All subsequent measurements of the bridge have recorded 976 feet. State highway maintenance records from 1940, 1955, 1973, and 1998 all show the same measurement. Modern GPS and laser surveying equipment confirms 976 feet. The bridge, as it exists and can be measured, is 976 feet long, but the original records remain. Lindstrom's construction logs, Sullivan's verification notes, and the surveying data from August 1934 all show 987 feet. The measurements were taken by experienced professionals using calibrated equipment. They were repeated and verified, and they were 11 feet longer than every measurement taken afterward. In 1997, a civil engineer named Patricia Moreno was researching historic infrastructure for a book on Depression-era public works projects. She obtained access to archived construction documents at the Washington State Archives and discovered Lindstrom's original surveying logs. When she compared them to current bridge specifications, she noticed the discrepancy. She contacted the Washington State Department of Transportation to inquire about the difference. The response, dated March 12, 1997, stated that the 1934 measurements had been later determined to be inaccurate due to equipment calibration issues and referred her to the Army Corps of Engineers report from 1936. Moreno requested a copy of that report through a FOA request. She received a heavily redacted version in August 1997. Most technical details were blacked out. The only clearly visible sections were the conclusion stating the correct measurement was 976 feet and a notation that original blueprints had been retained for security assessment purposes. Moreno attempted to interview surviving family members of the original surveying team. Lindstrom had died in 1968. Sullivan had passed away in 1981. Oakes died in 1959. Kowalski was located living in Bellingham, Washington, but declined to be interviewed, saying only that he'd signed documents in 1935 that prevented him from discussing the matter. Whitfield had died in 1947. Moreno submitted an article about the discrepancy to the Journal of Bridge Engineering in 1998. The article was rejected. The rejection letter stated that the described discrepancy appears to be based on historical documentation error rather than actual structural anomaly, and therefore does not meet publication standards. In 2002, a structural engineering firm was hired to conduct a comprehensive assessment of Deception Pass Bridge as part of long-term maintenance planning. The firm, Morrison and Associates, used laser scanning technology to create a precise three-dimensional model of the entire structure. The main span measured 976 feet. The measurements were accurate to within 0.01 feet. One of the engineers on the Morrison team, a man named Dr. Raymond Gutierrez, noticed something unusual in the laser scan data. The steel members and connection points matched the original design specifications, the design that had called for a 987-foot span. The structural elements were sized and positioned for a longer bridge, but the physical span was 976 feet. The components existed for a bridge that was 11 feet longer than the bridge that was actually there. Gutierrez documented this observation in an internal memo dated June 5, 2002. He suggested that either the design specifications had been changed during construction or the laser scan data was misinterpreting the structural configuration. He recommended comparing the scan results to the original blueprints to resolve the discrepancy. Morrison and Associates requested the original blueprints from the Washington State Department of Transportation. They were told the blueprints were held by the Army Corps of Engineers and would require federal authorization to access. Morrison applied for access in July 2002. The request was denied in September 2002 with no explanation beyond security classification. Gutierrez retired from Morrison and Associates in 2004. In 2009, he was contacted by a researcher from the University of Washington named Angela Torres, who had learned about the bridge discrepancy while studying historical engineering projects. Gutierrez confirmed his observations from the laser scan and provided copies of his internal memos. He said he'd never received a satisfactory explanation for why structural components designed for a 987-foot span existed on a bridge that measured 976 feet. Torres filed a new FOIA request for the original blueprints in 2010. The request was acknowledged but never fulfilled. After multiple follow-up inquiries, she received a letter in 2011 stating that the documents she requested were classified under national security protocols and cannot be released to non-cleared personnel. The letter included a reference to United States Code Title 50, which governs war and national defense, not civilian infrastructure. The bridge continues to carry traffic. Thousands of vehicles cross it daily. The span measures 976 feet by every modern method of measurement. The structural assessment in 2002 found it safe and sound, requiring only routine maintenance. Nothing about the bridge's physical presence suggests anything unusual, but the records remain inconsistent. 5 experienced surveyors in 1934 measured 987 feet. Their measurements were verified, repeated, and documented. 1 year later, federal surveyors measured 976 feet. The 11-foot difference was attributed to calibration error, but no evidence of such error was provided. The original blueprints were seized and classified. The surveyors were required to sign security acknowledgments, and a structural assessment in 2002 found components sized for a bridge that's 11 feet longer than the bridge that exists. Deception Pass still runs cold and fast beneath the bridge. The tidal currents still create whirlpools. And somewhere in federal archives, under security classifications typically reserved for weapon systems and military installations, there are blueprints for a bridge that measured 987 feet when it was built in 1934 and 976 feet when it was measured in 1935, a difference of 11 feet that vanished from official existence but remains present in the steel itself. In components designed for a span that no longer matches the distance they cross, as if something shortened the bridge without changing what it was made from, leaving behind only the question of what happened to 11 feet of structure that 5 people measured, documented, and swore existed before the government decided it never had. "42 people wrote down the same location before they disappeared, and none of them knew why." The Cascade Range in Washington state encompasses over 11,000 square miles of wilderness, much of it roadless and unmapped in any meaningful detail. The terrain includes glaciated peaks, dense old-growth forests, and river valleys so remote that searchers can spend weeks combing an area without covering it comprehensively. The Snoqualmie National Forest, which contains the coordinates in question, was established in 1908 and merged with other forest designations over subsequent decades. By the mid-20th century, it was a patchwork of designated wilderness, logging areas, and abandoned homesteads, a landscape where people could vanish with alarming ease. Disappearances in the Cascades have always been common enough to generate statistical background noise. Hikers misjudge distances. Hunters get turned around in fog. Solo climbers fall. The terrain is unforgiving, and search and rescue teams operate under the assumption that most missing persons will either self-rescue or be found deceased within a predictable radius of their last known location. What made the 42 cases unusual wasn't the disappearances themselves, it was the coordinates. The pattern wasn't recognized until 1991, when a King County Sheriff's detective named Gerald Strand was reviewing cold cases as part of a database digitization project. Strand had been assigned to input decades of missing person reports into a new computer system, a tedious process that involved reading through hundreds of paper files. In March 1991, he noticed something while entering a case from 1984. A missing hiker named Thomas Whitmore had written a set of coordinates in his trail journal 2 days before he vanished. The coordinates were 47.1234 north, 121.4567 west. Strand thought the precision was unusual. Most hikers don't record coordinates to 4 decimal places. He made a note of it and continued his work. 3 weeks later, he encountered another case from 1976 involving a missing forestry worker named Dorothy Lindstrom. Her supervisor had found a piece of paper in her truck with the same coordinates written in her handwriting. Lindstrom had disappeared while conducting a timber survey and was never found. Strand began searching specifically for coordinate references in the missing person files. Over the next 6 months, he identified 42 cases spanning from 1963 to 1987 where the same coordinates appeared in some form. The victims had written them in journals, on maps, on scraps of paper, and, in 3 cases, carved into trees near their last known locations. The coordinates were always recorded within 48 hours of the person's disappearance. None of the victims had explained why they'd said, "Written the coordinates." Most hadn't mentioned them at all. The victims varied in age, background, and experience level. They included day hikers, experienced mountaineers, forestry workers, hunters, and Forest Service employees. The disappearances occurred in different seasons and different areas of the Cascades, though all were within roughly 50 miles of the coordinates themselves. 16 of the 42 had been the subject of extensive search operations. None were ever found. Strand filed a report with his supervisor in September 1991. He recommended that the coordinates be investigated as a potential link between the cases. His supervisor, a lieutenant named Margaret Sullivan, reviewed the report and agreed it warranted attention. She contacted the Forest Service and requested information about the location indicated by the coordinates. The coordinates pointed to a clearing in the Snoqualmie National Forest, approximately 2 miles south of the town of Easton, Washington. The location was accessible by logging roads and was not particularly remote by Cascade standards. It sat at an elevation of roughly 2,300 feet in a valley surrounded by second-growth forest. There was nothing obviously significant about it. No historical sites, no known hazards, no geological features of note. In October 1991, Strand and a Forest Service ranger named Patricia Moreno visited the site. They used GPS units to navigate to the exact coordinates. What they found was an unremarkable clearing, roughly 40 feet in diameter, with sparse vegetation and rocky soil. The clearing was surrounded by Douglas fir and western hemlock. A seasonal creek ran approximately 100 yards to the east. There were no structures, no signs of recent human activity, and no obvious reason why 42 people would have independently recorded these coordinates. Moreno noted that the vegetation in the clearing was unusually sparse. The surrounding forest was dense, but the clearing itself supported only scattered grasses and low shrubs. She collected soil samples for analysis. Strand photographed the site and documented its features. They spent approximately 3 hours at the location, walking the perimeter and looking for anything unusual. They found nothing that seemed relevant. The soil samples were sent to the Washington State University Extension Service for analysis. The results, returned in November 1991, showed normal soil composition for the region: volcanic ash, decomposed organic matter, typical mineral content. The report noted one anomaly. The soil showed remarkably low biological activity. Bacterial counts were significantly below expected levels. The analysis suggested this might be due to recent disturbance or contamination, though no contaminants were detected. Strand contacted a microbiologist at the University of Washington, Dr. Raymond Gutierrez, to inquire about the low bacterial count. Gutierrez reviewed the soil analysis and agreed to visit the site. In December 1991, Gutierrez collected additional samples from multiple locations within and around the clearing. His analysis, completed in February 1992, confirmed the original findings. Within a roughly 15-foot radius of the coordinate center point, soil samples showed virtually no bacterial life, no fungal presence, and no microarthropods. The soil was, in Gutierrez's words, biologically sterile in a way that doesn't occur naturally in forest environments. Gutierrez found this disturbing enough to recommend further investigation. He suggested that the sterility might indicate chemical contamination, though none had been detected, or some form of radiation exposure, though his measurements showed normal background radiation levels. He couldn't explain the phenomenon with available data. Strand expanded his investigation. He contacted family members of the missing persons whose cases included the coordinates. In most cases, families had no knowledge of why their relatives had written down the location. Several mentioned that the missing person had seemed distracted or preoccupied in the days before disappearing. One family member, the sister of a missing hiker named Robert Kowalski, who vanished in 1979, said her brother had mentioned feeling pulled towards something in the mountains, but hadn't elaborated. Another family member, the wife of a missing forestry worker named James Oakes, who disappeared in 1968, said she'd found a notebook in his belongings after he vanished. The notebook contained the coordinates written repeatedly across several pages, along with the phrase, "need to see it," written multiple times. She'd given the notebook to investigators at the time, but it hadn't been considered significant in the original investigation. Strand attempted to locate the notebook in archived evidence, but was unable to find it. The case file from 1968 made no mention of a notebook, though the wife insisted she'd provided it. In March 1992, Strand submitted a comprehensive report to the King County Sheriff's Office summarizing his findings. The report documented the 42 cases, the repeated coordinates, the site investigation, and the soil analysis. He recommended that the case be referred to the FBI's Behavioral Analysis Unit for profile development and that additional scientific analysis of the site be conducted. The Sheriff's Office forwarded the report to the FBI in April 1992. The FBI response, received in June 1992, stated that the cases did not meet criteria for federal investigation. The response noted that the disappearances occurred over a 24-year period in a region with high rates of missing person incidents, and that the presence of identical coordinates in victim records, while unusual, does not establish a clear pattern of criminal activity or constitute evidence of serial predation. Strand disagreed, but had limited options for further investigation. He contacted the Washington State Patrol and several academic researchers who specialized in missing person cases. None expressed interest in pursuing the matter. The cases remained classified as individual missing person investigations with no established connection beyond the coordinate anomaly. In 1994, a journalist from the Seattle Times named Ellen Vasquez learned about Strand's research and wrote an article titled "The Coordinates Mystery, 42 Missing, One Location." The article appeared in the July 17, 1994 edition and provided a detailed account of the cases and the investigation. It included interviews with Strand, Gutierrez, and several family members of the missing persons. The article generated public interest but no new leads. Several amateur investigators visited the coordinate site over the following years. None reported finding anything significant. The Forest Service placed no restrictions on access to the area, and it remained an unmarked clearing in an unremarkable section of forest. In 2003, Gutierrez returned to the site with updated equipment to conduct a more comprehensive biological survey. He collected samples from a grid pattern covering approximately 1 acre surrounding the coordinates. His analysis confirmed his earlier findings. Within a 15-foot radius of the center point, soil samples showed minimal biological activity. Outside that radius, biological activity was normal for the region. The boundary was remarkably precise. Samples taken 14 feet from center showed normal bacterial counts, while samples taken 16 feet from center showed normal counts. The 15-foot radius appeared to be a clear demarcation. Gutierrez published his findings in a soil science journal in 2004. The paper described the biological sterility as unexplained by known mechanisms and recommended further study. The paper received minimal attention from the scientific community. No new disappearances linked to the coordinates have been documented since 1987. Strand retired from the King County Sheriff's Office in 2006. He continued to research the cases independently until his death in 2014. In his personal files donated to the University of Washington after his death, researchers found detailed notes documenting his visits to the coordinate site. He'd returned there more than 30 times between 1991 and 2013, always looking for something that might explain why 42 people had written down the location before vanishing. The clearing still exists. The coordinates still point to the same unremarkable spot in the forest south of Easton. The soil within 15 feet of the center point still shows no bacterial life, no fungi, no microorganisms. Nothing grows there beyond sparse, struggling vegetation that never seems to thrive. And in archived case files across 3 decades, 42 people left behind the same numbers, written in journals, carved in trees, scrawled on maps, a location none of them explained, a place that pulled them towards something they couldn't describe, coordinates that led to a clearing where the ground itself refuses to support life, as if something happened there that sterilized the earth in a perfect circle and called to 42 people across 24 years, drawing them into the Cascades where they vanished without explanation, leaving behind only numbers that point to emptiness and soil that won't sustain even the microscopic life that exists everywhere else, a 15-foot radius of silence in the forest where nothing lives, and 42 people felt compelled to go. On one evening in the North Cascades, the sun forgot how to set. Stehekin sits at the northwestern tip of Lake Chelan, accessible only by boat, float plane, or a 23-mile hike through wilderness. No roads connect it to the outside world. The community of roughly 75 permanent residents exists in deliberate isolation, surrounded by North Cascades National Park on 3 sides and the 55-mile-long lake on the 4th. The name comes from a Salishan word meaning the way through, referencing the Stehekin River Valley that serves as one of the few natural corridors through the Cascade Range. The Chelan people knew the valley as a threshold place, where the ordinary rules of the world sometimes bent. Early settlers reported temporal distortions, days that felt too long, nights that seemed compressed, but attributed these sensations to the extreme isolation and the way mountains blocked the sun for extended periods. By the 1970s, Stehekin had become a destination for those seeking remoteness. Tourism was minimal and carefully controlled. The National Park Service maintained a small ranger station. A single lodge offered accommodations. Most residents lived off-grid, generating their own power and relying on supply boats that made regular runs up the lake from the town of Chelan, 55 miles to the southeast. Time moved differently in Stehekin, but only in the metaphorical sense, until August 3, 1977, when the difference became measurable. The day had been unremarkable. Clear skies, temperature in the mid-70s, a typical summer day in the high Cascades. Approximately 20 tourists were staying at the lodge. Another dozen were camping in the national park. The permanent residents were going about their usual routines. At 7:43 p.m. Pacific Daylight Time, the sun began its descent toward the ridgeline west of the valley. Multiple residents noted the time because it marked the beginning of evening routines, dinner preparation, closing of the lodge's outdoor seating, the ranger station's shift change. What happened next was observed by at least 47 people, documented by multiple timepieces, and confirmed by astronomical calculations performed after the fact. The sun descended normally until it touched the western ridge at approximately 8:11 p.m. At that point, according to every witness, it stopped descending. Not completely motionless, the sun continued to move along the horizon, traveling slowly southward. But it did not sink below the ridgeline. It remained balanced on the mountain's edge, half visible, for what witnesses described as an impossibly long time. A lodge employee named Walter Kowalski was the first to comment on the phenomenon. He mentioned to another employee, Dorothy Rafferty, that the sunset was taking longer than usual. Rafferty checked her wristwatch, a mechanical Timex she'd owned for 3 years. She noted the time as 8:17 p.m. Both employees continued watching. The sun remained at the horizon. By 8:25 p.m., other residents and tourists had noticed. A group of hikers who'd returned from a day trek stood on the lodge's deck, watching the sun refuse to set. One of them, a schoolteacher from Portland named Margaret Sullivan, had a watch with a second hand. She began timing the phenomenon, counting the minutes the sun remained visible after it should have disappeared. A National Park Service ranger named Thomas Lindstrom was at the ranger station approximately half a mile from the lodge. He'd stepped outside at 8:30 p.m. for routine observations and noticed the sun still visible on the horizon. He checked the station's clock, synchronized weekly with radio time signals, and noted the discrepancy. According to his calculations, based on tables published by the Naval Observatory, sunset should have occurred at 8:22 p.m. It was now 8 minutes past that time, and the sun was still visible. Lindstrom retrieved a camera from the station, a Nikon F2 with Kodachrome 64 film, and began photographing the sun's position at 2-minute intervals. He took 7 photographs between 8:32 and 8:44 p.m. Each photograph showed the sun at the horizon, partially obscured by the western ridge, but clearly visible. At the lodge, Sullivan continued timing. She was now joined by 14 other observers, several of whom had their own timepieces. A tourist named Robert Tanaka had a digital watch, then a relatively new technology. A retired engineer named Bernard Whitmore had a chronometer he'd used in his navigation work. All confirmed the same thing. The sun was not setting according to the expected timeline. At 8:39 p.m., a photographer from Seattle named Patricia Moreno, who was staying at the lodge, set up a tripod and began taking long exposure photographs of the landscape with the sun at the horizon. She used a Pentax K1000 with Ektachrome film. She took 4 photographs between 8:39 and 8:46 p.m., carefully documenting the time of each exposure in a field notebook she carried. The sun finally disappeared below the ridgeline at 8:40 p.m. Multiple witnesses confirmed this time. Sullivan had timed the visible sunset at 18 minutes past the predicted moment. Lindstrom's calculations, performed that evening using Naval Observatory data, confirmed that astronomical sunset, the moment when the sun's upper edge should disappear below the horizon, had been predicted for 8:22 p.m. The sun had remained visible until 8:40 p.m. 18 minutes of discrepancy. The witnesses discussed the phenomenon that evening at the lodge. The consensus was that some atmospheric effect, unusual refraction perhaps, or a mirage caused by temperature layers, had made the sun appear to remain at the horizon longer than it actually had. But several observers, including Whitmore, the retired engineer, noted that atmospheric effects typically distort the sun's shape. The sun they'd observed had maintained its normal appearance. It simply hadn't descended at the expected rate. Lindstrom filed a report with the National Park Service on August 5, 1977. His report described the extended sunset, included his time observations and calculations, and noted that he'd photographed the phenomenon. He requested that the photographs be analyzed by experts who might explain the discrepancy. Moreno returned to Seattle on August 6th and dropped her film at a professional development lab she'd used for years. When she retrieved the developed slides on August 13th, 3 of the 4 sunset photographs showed normal results. The landscape correctly exposed, the horizon visible. but the sun itself appeared as an overexposed white blob in each image, far brighter than she'd metered for, with no detail visible. The lab had attached a note: exposure error on slides 8, 9, and 10. Sun overexposed. Please check meter calibration. Moreno insisted her meter was correctly calibrated and that she'd metered specifically for the sun's brightness. The lab suggested she might have metered for the landscape rather than the sun itself, causing overexposure. Moreno knew her own technique well enough to dismiss this, but had no explanation for why the sun appeared overexposed in properly metered photographs. Lindstrom's photographs were sent to the National Park Service Regional Office in Seattle. In September 1977, he received them back with a memo stating that photographic evidence shows normal sunset conditions with possible lens flare effects. No atmospheric anomaly apparent in images. Lindstrom reviewed the returned photographs. Like Moreno's, his images showed the landscape correctly exposed, but the sun itself blown out, pure white, with no solar disk detail visible. He'd used a camera and film he'd relied on for years. He'd metered carefully. The results made no sense. Sullivan, the school teacher, had not taken photographs but had documented the event in her journal. She wrote to the American Astronomical Society in October 1977, describing what she'd witnessed and asking whether any known atmospheric phenomena could cause such a pronounced delay in sunset. She received a reply in November from an astronomer named Dr. Raymond Gutierrez. His letter stated that atmospheric refraction could cause the sun to appear visible for approximately 2 to 3 minutes longer than geometric calculations would predict, but 18 minutes was far beyond any documented refraction effect. He suggested that the witnesses might have misread their timepieces or that local topography created an illusion of prolonged sunset. Sullivan shared Gutierrez's letter with other witnesses. Several took offense at the suggestion they'd misread their watches. Tanaka, the tourist with the digital watch, wrote his own letter to Gutierrez, describing the phenomenon in detail and noting that his watch had been checked against radio time signals before and after the event, showing no error. Gutierrez did not reply. In December 1977, Lindstrom contacted the Naval Observatory directly, providing his calculations and requesting verification. In January 1978, he received a response confirming that sunset on August 3, 1977, at Stehekin's coordinates, 48.35 degrees north, 120.68 degrees west, should have occurred at 8:22 p.m. Pacific Daylight Time, with an uncertainty of less than 1 minute due to local topography. The sun should not have remained visible until 8:40 p.m. under any standard atmospheric conditions. 3 other amateur photographers among the witnesses had also taken pictures that evening. A tourist named Ellen Vasquez used a Kodak Instamatic. A local resident named James Oakes used a Polaroid SX70. Another tourist, whose name was recorded only as M. Brennan in the lodge's guest register, used an unknown camera model. All 3 had their film developed at different locations: Vasquez in California, Oakes at a pharmacy in Wenatchee, and Brennan presumably wherever he lived. As he'd checked out of the lodge the day after the event and left no forwarding information. Vasquez's photographs, returned in late August, showed the same problem: correctly exposed landscape, overexposed sun. Oakes's Polaroid images, developed instantly at the time, showed similar issues. The instant prints captured the landscape, but rendered the sun as a blown-out white circle. Brennan was never located for follow-up. In March 1978, a journalist from the Wenatchee World newspaper, a woman named Angela Torres, learned about the incident and traveled to Stehekin to interview witnesses. Her article, published April 2, 1978, described the extended sunset and included testimony from multiple witnesses. The article generated regional interest but no scientific follow-up. Lindstrom attempted to interest university researchers in the phenomenon. he contacted astronomy departments at the University of Washington, Washington State University, and the University of Oregon. None expressed interest in investigating. A professor from the University of Washington replied with a letter suggesting the witnesses had experienced a collective observational error influenced by environmental factors and group dynamics. The photographs remained problematic. 7 different people, using 5 different camera types and 3 different film stocks, had captured images that showed correctly exposed landscapes but overexposed suns. Professional photographers, when shown the images, could offer no explanation beyond metering error, but 7 photographers making identical metering errors on the same evening seemed unlikely. In 1985, Sullivan, who'd kept detailed notes on the incident, submitted a paper to the Journal of Atmospheric Sciences describing the event and requesting explanation. The paper was rejected in 1986 with a reviewer comment stating that the described phenomenon lacks physical plausibility and the supporting evidence is primarily testimonial. Lindstrom retired from the Park Service in 1992. He'd kept copies of all his documentation related to August 3, 1977. In 2004, he donated these materials to the North Cascades Institute, an educational organization based in the region. The materials included his original field notes, his calculations, his correspondence with the Naval Observatory, and the returned photographs showing the overexposed sun. In 2009, a researcher named Dr. Priya Mehta from Portland State University, studying historical accounts of atmospheric anomalies in the Pacific Northwest, came across Lindstrom's archived materials. She interviewed Lindstrom, then 81 years old, who confirmed every detail of his account. She also located Sullivan, Kowalski, and 3 other surviving witnesses. All maintained that the sunset had lasted 18 minutes longer than it should have, that they'd timed it carefully, and that they'd never received an adequate explanation. Mehta attempted to reconstruct the event using modern atmospheric modeling software. No combination of refraction, temperature inversion, or optical effects could produce an 18-minute delay in sunset. She concluded her research paper, published in 2011 in a minor meteorology journal, by stating that the Stehekin sunset of August 3, 1977 remains unexplained by conventional atmospheric science. Stehekin remains isolated. Sunsets occur according to astronomical predictions, varying only by the 2 to 3 minutes that refraction typically allows. No similar event has been reported since 1977, but in archives at the North Cascades Institute, there are 7 photographs from that evening, 7 different cameras, 5 types of film, all showing the same impossibility. Landscapes exposed correctly, the sun burned into white oblivion, as if something about that particular sunset on August 3, 1977, was too bright for film to capture, while 47 people stood in a mountain valley and watched the sun pause at the horizon for 18 minutes, refusing to set, defying calculation and observation, and every mechanism by which light and time are supposed to work, until finally it descended and left behind only testimony, overexposed photographs, and the question of what happened during those 18 extra minutes when the sun remained visible in a place where time moves differently, where the way through the mountains sometimes holds back the night, and where just once, the astronomical certainty of sunset failed, leaving witnesses to wonder whether the sun had actually paused, or whether they and their watches and their careful measurements had somehow moved 18 minutes out of sync with the rest of the world, while the sun set normally, and they alone continued existing in a moment that should have already ended. Some conversations exist in a language that predates the people speaking it. Mount Baker rises 10,781 feet in the North Cascades of Washington State, a glaciated volcano that last erupted in 1843 but continues to emit steam from fumaroles near its summit. The mountain anchors the Mount Baker Snoqualmie National Forest, over 1.7 million acres of wilderness where dense old-growth forests give way to alpine meadows and permanent snowfields. Fire lookout towers dot the high ridges, staffed during summer months by Forest Service employees who spend weeks alone scanning for smoke. The isolation is profound. Some towers are accessible only by trail, supplied by pack mules or helicopter. Rangers who work these positions accept loneliness as a condition of employment. The Kulshan Ridge Lookout sits at 6,400 feet on Mount Baker's northwestern flank, overlooking the Nooksack River Valley. Built by the Civilian Conservation Corps. In 1938, it's a standard L4 cab design, a 14 by 14-foot room mounted on a 40-foot tower, with windows on all sides and a catwalk for exterior observation. The lookout operates from late June through September, staffed by a single ranger who lives in the cab for the entire season. Supplies are delivered every 2 weeks by trail crew. Radio contact with the district office occurs twice daily. Beyond that, the ranger is alone. In 1995, the lookout was staffed by a man named Gerald Kowalski, age 34, who'd worked fire lookouts for the Forest Service for 6 summers. Kowalski was experienced, reliable, and preferred solitary assignments. He arrived at Kulshan Ridge on June 26, 1995, and began his season without incident. His radio check-ins were routine. His fire reports were accurate. District rangers who communicated with him noted nothing unusual in his demeanor or his reports. On August 19, 1995, Kowalski failed to make his evening radio check-in at 6 p.m. This was unusual, but not immediately alarming. Equipment failures and atmospheric interference occasionally disrupted communications. When he missed his morning check-in on August 20th, the district ranger, a woman named Patricia Moreno, decided to investigate. The lookout was a 4-hour hike from the nearest trailhead. Moreno and another ranger, Thomas Rafferty, left the ranger station at 7 a.m. on August 20th and reached the lookout at approximately 11:15 a.m. They found the tower intact, the cab door closed but unlocked. Kowalski was not present. His personal belongings remained in the cab: sleeping bag, clothing, food supplies, books. His radio equipment was functional. Nothing appeared disturbed. But on the small desk where Kowalski kept his logbook and fire reports, Moreno found 17 cassette tapes arranged in a precise grid pattern, 3 rows of 5 with 2 additional tapes centered below. Each tape was labeled with a date, starting with August 10th and ending with August 18th. The dates were written in Kowalski's handwriting, which Moreno recognized from his reports. She collected the tapes and initiated a search for Kowalski. Rafferty hiked the perimeter trails while Moreno radioed for additional search personnel. Over the next 3 days, 12 Forest Service employees and volunteers searched a 5-mile radius around the lookout. They found no trace of Kowalski. No equipment was missing, no signs of struggle or injury. He had simply left the tower and disappeared. Moreno brought the cassette tapes to the district office on August 23rd. She played the first tape, dated August 10th. The recording contained approximately 43 minutes of conversation between 2 male voices. One voice was clearly Kowalski's. Moreno recognized his speech patterns and slight Oregon accent. The second voice was unfamiliar. The conversation was calm, unhurried, and deeply strange. The voices discussed something they referred to as the count. The unfamiliar voice asked how many remained. Kowalski's voice replied with numbers, sometimes specific figures, sometimes ranges. The unfamiliar voice acknowledged these numbers and made statements about completion and the threshold. The conversation repeated certain phrases. When the count reaches completion, the boundary requires precision. The names must be accurate. Moreno played all 17 tapes over the following days. Each tape contained a similar conversation, approximately 40 to 45 minutes in length. The voices discussed the count, completion, boundaries, and names. The numbers changed from tape to tape, initially in the hundreds, gradually decreasing toward single digits in the final recordings. The tone remained consistent, calm, methodical, neither urgent nor emotional. What disturbed Moreno most was the content's specificity combined with its incomprehensibility. The conversation sounded purposeful, as if discussing concrete tasks, but the meaning remained opaque. The unfamiliar voice used grammatical constructions that sounded archaic, word orders and phrasings that felt wrong, though Moreno couldn't articulate exactly why. She contacted the Regional Forest Service office in Portland on August 25th and reported both Kowalski's disappearance and the discovery of the tapes. The regional supervisor, a man named Douglas Lindstrom, requested copies of the recordings. Moreno made duplicates and sent them to Portland on August 26th. The search for Kowalski continued through early September with no results. His family was notified. Missing person reports were filed with local law enforcement. Search dogs were brought in but found no scent trails beyond the immediate vicinity of the lookout tower. Kowalski had effectively vanished. Lindstrom sent the tapes to the Forest Service's Regional Investigation Unit, which forwarded them to the FBI's field office in Seattle for voice analysis. In October 1995, the FBI returned a preliminary report. Voice analysis confirmed that one speaker was Gerald Kowalski, matched against recordings from his ranger training and radio communications. The second voice could not be identified. It did not match any known voice in law enforcement databases. Linguistic analysis noted unusual speech patterns consistent with what the analyst described as archaic English grammatical structures, possibly Middle English period, approximately 13th to 15th century. The FBI report included a transcript of portions of the August 18th recording, the final tape. The conversation included the following exchange. First voice, Kowalski. The count stands at 7. Second voice. Unidentified. 7 remaineth. The completion draweth nigh. First voice. Will it be enough? Second voice. The boundary requireth precision. Each name must be spoken. Each one must be marked. First voice. I understand. Second voice. When the count reacheth naught, thou shalt cross, the threshold shall open. The transcript noted that the second voice consistently used grammatical forms, remaineth, draweth, reacheth. That hadn't been standard English for centuries. The analyst suggested this might indicate a non-native speaker who'd learned English from historical texts, or someone deliberately affecting an archaic style. Moreno found this explanation unsatisfying. She'd listened to all 17 tapes multiple times. The archaic voice didn't sound affected. It sounded native, fluent, entirely natural in its strangeness. In November 1995, Lindstrom contacted Dr. Raymond Gutierrez, a linguist at the University of Washington specializing in historical English dialects. Gutierrez agreed to analyze the tapes. His report, completed in January 1996, confirmed the FBI analyst's findings. The second voice used Middle English grammatical structures with remarkable consistency. Gutierrez noted that modern speakers attempting to mimic Middle English typically make errors or inconsistencies. This voice made none. It used archaic structures perfectly, as if it were the speaker's natural language. Gutierrez also noted something else. The vocabulary was modern. Words like boundary, threshold, and count were used in their contemporary senses, not their Middle English meanings. The result was a linguistic impossibility, someone speaking modern English vocabulary through grammatical structures that predated those vocabulary developments by centuries. The Forest Service interviewed Kowalski's family and friends in February 1996. No one reported any interest in historical linguistics, medieval studies, or archaic language. Kowalski had been a biology major in college, worked various outdoor jobs, and spent his free time hiking and fishing. He owned no books on medieval, history, or linguistics. His personal library, examined by investigators, consisted primarily of field guides, novels, and nature writing. Friends described him as rational, grounded, not given to elaborate pranks or unusual hobbies. His psychological evaluation from his most recent Forest Service employment review, conducted in 1994, showed no concerns. He was considered stable, competent, and well-suited to isolated duty. The Forest Service closed the active investigation in March 1996, classifying Kowalski's disappearance as missing under suspicious circumstances. The case remained open but inactive. The tapes were filed in the regional office's evidence storage. In May 1996, a journalist from the Seattle Times, a woman named Ellen Vasquez, learned about the case through law enforcement contacts and requested information under public disclosure laws. The Forest Service released a redacted incident report that confirmed a ranger had disappeared and unusual recordings had been found, but the actual tape contents were withheld as evidence in an ongoing investigation. Vasquez wrote an article that appeared in the June 9, 1996 edition, titled "Missing Ranger, Mysterious Tapes Baffle Forest Service." The article generated regional attention, but no new leads. Several amateur investigators contacted the Forest Service requesting access to the tapes. All requests were denied. In 2003, Moreno, who'd left the Forest Service in 1999 and was working as a wilderness guide, was contacted by a graduate student in folklore studies at the University of Oregon named Angela Torres. Torres was researching unexplained disappearances in the Cascade Range and had learned about Kowalski's case. Moreno agreed to be interviewed and shared her recollections of the tapes. Moreno said she'd made personal copies of several tapes before surrendering them to investigators. She'd listened to them repeatedly over the years, trying to understand what they meant. She described the experience as deeply unsettling, not because the voices were threatening, but because they sounded purposeful in a way that implied knowledge she didn't possess. They were discussing something real, Moreno said in the interview, something with rules and procedures, but the context was completely absent. It was like overhearing half of a conversation about a process you've never encountered. Torres asked whether Moreno believed the recordings were genuine, actual conversations between Kowalski and an unknown person, or some kind of fabrication. Moreno said she'd asked herself that question hundreds of times. The recordings sounded authentic. The voices interacted naturally, with pauses and responses that suggested genuine dialogue, not scripted performance. But the content was impossible. Who speaks Middle English naturally in 1995? And why would Kowalski participate in such a conversation? Torres attempted to obtain copies of the tapes through FOIA requests in 2004. The Forest Service denied the request, stating that the tapes remained evidence in an open investigation. Torres appealed. In 2005, the appeal was denied with a notation that the materials were potentially relevant to ongoing inquiries and exempt from disclosure. In 2009, Torres located Dr. Gutierrez, who'd performed the linguistic analysis in 1996. He confirmed his findings and said the case remained the strangest he'd encountered in 40 years of studying historical English. He'd never heard anyone speak with that combination of grammatical accuracy and temporal impossibility. When Torres asked whether the voice could have been artificial, computer-generated, or synthesized, Gutierrez said the technology to produce such naturalistic speech with those specific linguistic features didn't exist in 1995. and even with modern technology would be extraordinarily difficult to achieve. The Kulshan Ridge Lookout was staffed normally in the summers following Kowalski's disappearance. Rangers reported no unusual occurrences. The tower was eventually decommissioned in 2007 as part of a broader Forest Service restructuring that closed several remote lookouts. It now stands unmaintained, accessible only to hikers willing to make the 4-hour climb from the trailhead. Kowalski was never found. His case remains officially open with the King County Sheriff's Office, though no active investigation continues. His family held a memorial service in 2001, marking him as presumed deceased. The 17 cassette tapes remain in Forest Service storage, cataloged but rarely accessed. Moreno's personal copies, which she kept for years, were lost when her house flooded in 2012. No other copies are known to exist outside official custody. What remains is testimony. Moreno's account of finding the tapes. The FBI voice analysis confirming Kowalski's voice paired with an unidentifiable speaker using Middle English grammar. Gutierrez's linguistic report describing an impossibility. Someone speaking naturally in a grammatical system that predated modern English by centuries, discussing a count that reached completion and a threshold that would open when the count reached naught. And somewhere in the records, the transcript of that final conversation on August 18, 1995. Kowalski confirming the count stood at 7, the archaic voice speaking of completion and crossing, and Kowalski's final recorded words, "I understand." The tower stands empty on Kulshan Ridge. The windows look out over the same valleys Kowalski watched for smoke in the summer of 1995. And in the silence of that abandoned room where 17 tapes were once arranged in a precise grid, there remains only the question of what Kowalski understood, what count he was keeping, and where he crossed when the threshold opened, and the count, whatever it was counting, finally reached completion. Some roads lose distance the way others lose travelers. State Route 20, known as the North Cascades Highway, crosses Washington State from the coastal lowlands near Burlington through the Cascade Range to the high desert plateau near Okanogan. The highway was completed in 1972 after decades of construction, cutting through some of the most rugged terrain in the continental United States. It climbs to Washington Pass at 5,477 feet, threading between peaks that exceed 8,000 feet and traversing avalanche zones so severe the highway closes every winter from approximately November through April. The route was controversial during construction. Environmentalists opposed the intrusion into wilderness, engineers questioned the feasibility, and indigenous Skagit and Methau peoples noted the highway crossed areas they'd traditionally avoided, places where the landscape was said to fold in ways that defied ordinary geography. The Washington State Department of Transportation maintains detailed records of every state highway, including precise mileage measurements used for maintenance planning, emergency response, and federal funding calculations. These measurements are updated periodically using professional surveying equipment. According to official WSDOT records, State Route 20 measures 437 miles from its western terminus at Interstate 5 near Burlington to its eastern terminus at U.S. Route 97 near Okanogan. This measurement has appeared in official documentation since the highway's completion in 1972. The discrepancy first became apparent in 2004, when the department began integrating GPS technology into its highway inventory systems. A transportation engineer named Walter Kowalski was tasked with verifying highway mileages using GPS units mounted in department vehicles. Between May and August 2004, Kowalski drove State Route 20 multiple times, recording GPS tracks that calculated total distance with precision unavailable to earlier surveying methods. His GPS readings consistently showed 434.1 miles. He rechecked his equipment. He drove the route again. The result remained the same, approximately 2.9 miles shorter than official records indicated. Kowalski documented the discrepancy in a report dated September 2, 2004, and submitted it to his supervisor, a woman named Patricia Moreno. Moreno initially assumed equipment error or miscalibration. She assigned another engineer, Thomas Rafferty, to verify Kowalski's measurements using different GPS equipment. Rafferty's survey, conducted in October 2004, produced nearly identical results, 434.2 miles. The highway was consistently measuring shorter than its official length. In November 2004, WSDOT contracted with a private surveying firm, Morrison Engineering Associates, to conduct a comprehensive measurement of State Route 20 using professional-grade GPS equipment and traditional surveying methods. The firm's report, delivered in February 2005, confirmed the GPS measurements, 434.2 miles. The report included odometer readings from the survey vehicle, which also recorded 434.2 miles. Morrison's report noted something else. The discrepancy appeared concentrated in a specific section of highway between milepost 162 and milepost 167, near Washington Pass. When surveyors drove this section, their GPS tracks showed anomalies, brief gaps in coverage, sudden jumps in recorded position, and timestamps that didn't align with the recorded speeds. The report characterized these as probable GPS signal interference due to terrain and atmospheric conditions, a common occurrence in mountainous regions where satellite signals are obstructed by peaks or reflected by rock faces. WSDOT's response was to update their records. In March 2005, the official length of State Route 20 was revised to 434.2 miles. Internal memos characterized the previous measurement as legacy surveying error from the 1970s, when less precise equipment had been used. The matter was considered resolved. Except drivers had already noticed something strange about the Washington Pass section. In July 2006, a truck driver named Margaret Sullivan filed a report with the Washington State Patrol after experiencing what she described as lost time while driving State Route 20 eastbound. Sullivan had been hauling freight from Seattle to Wenatchee, a route she'd driven hundreds of times. She'd noted her time passing the town of Marblemount, 3:47 p.m., and her time reaching the town of Mazama, 4:51 p.m. The distance between these points is approximately 63 miles. At her average speed of 55 miles per hour, accounting for the winding mountain road, she should have taken roughly 70 to 75 minutes. She'd taken 64 minutes. Sullivan was certain of her times. Her delivery logs required precise timestamps, and she habitually noted her position at known landmarks. She'd driven through the Washington Pass section, the highest and most memorable part of the route, but had no specific memory of it. One moment she was climbing into the mountains past Marblemount, the next she was descending toward Mazama. The intervening section, roughly 20 miles, felt absent from her recollection. The state patrol officer who took her report, a trooper named Douglas Lindstrom, noted it as possible fatigue-related microsleep and advised her to rest before continuing. Sullivan insisted she hadn't been drowsy and hadn't experienced any gap in consciousness. She'd been aware the entire drive, listening to the radio, monitoring her speed. She simply couldn't remember the Washington Pass section, and her timestamps didn't match the expected travel time. Lindstrom filed the report and thought nothing more of it until September 2006, when he received a similar report from a tourist named Robert Tanaka. Tanaka had been driving westbound through Washington Pass and experienced what he described as arriving at his destination sooner than expected. He'd timed his drive carefully, planning to reach the town of Concrete by a specific hour. He'd arrived 4 minutes early, despite driving at posted speed limits and stopping once for photographs. Like Sullivan, he had clear memories of the drive before and after Washington Pass. But the pass itself was vague, a sense of having driven through without active attention. Over the following year, Lindstrom collected 6 more reports of similar experiences, all occurring on the stretch of State Route 20 between mileposts 162 and 167. Drivers consistently reported arriving earlier than expected, with timestamps that didn't align with distance and speed. Most described the Washington Pass section as feeling shorter than it should be, or like it went by faster than normal. None reported any dangerous conditions or concerns beyond the temporal discrepancy. Lindstrom compiled these reports and submitted them to the State Patrol's Traffic Safety Division in November 2007. His report suggested that unusual driving conditions in the area might be causing drivers to misjudge their speed or experience altered time perception. He recommended additional speed enforcement and signage warning of the highway's demanding curves. The Traffic Safety Division reviewed Lindstrom's report and consulted with WSDOT. In December 2007, a joint working group was formed to investigate. The group included transportation engineers, traffic safety specialists, and a psychologist from the University of Washington, Dr. Raymond Gutierrez, who specialized in driver perception and attention. Between March and June 2008, the working group conducted a study. They recruited 40 volunteer drivers and had them drive State Route 20 while being monitored. Each vehicle was equipped with GPS tracking, dashboard cameras, and devices that recorded speed, acceleration, and braking. Drivers were asked to estimate travel times and note any unusual experiences. The results, documented in a report dated August 2008, were inconclusive but suggestive. Of the 40 drivers, 11 reported that the Washington Pass section felt shorter than they expected based on the landscape and driving time. GPS data from these 11 vehicles showed minor anomalies, brief gaps in satellite tracking, small discrepancies between GPS calculated distance and odometer readings, consistent with signal interference. Dashboard. Cameras showed the drivers remained attentive and maintained appropriate speeds. More interesting was the timing data. When researchers compared actual drive times through the section against predicted times based on distance and recorded speeds, they found a consistent pattern. Drivers completed the section an average of 3.2 minutes faster than predictions indicated they should. The difference was small but statistically significant. Something about that stretch of highway, whether the geometry of the curves, the visual perception of distance, or some other factor, resulted in measurably faster transit times than expected. Dr. Gutierrez's psychological analysis suggested this might be explained by highway hypnosis, a well-documented phenomenon where drivers enter a trance-like state on monotonous roads and complete stretches without conscious memory. But the Washington Pass section was far from monotonous. It included dramatic elevation changes, sharp curves, and spectacular vistas. Highway hypnosis typically occurred on straight, featureless roads, not mountain passes. The working group's final report, published in October 2008, concluded that minor perceptual anomalies related to terrain, elevation changes, and visual distance estimation may contribute to driver experiences of altered time perception on State Route 20 near Washington Pass. The report recommended no changes to highway infrastructure or signage, noting that no safety concerns had been identified. Lindstrom found the report unsatisfying. He documented not just subjective feelings, but objective timestamps. Drivers arriving earlier than physics should allow based on distance and speed. The working group had confirmed faster transit times, but attributed them to measurement uncertainty and driver behavior. Lindstrom believed something else was occurring, though he couldn't articulate what. In 2010, a journalist from the Seattle Times, a woman named Ellen Vasquez, learned about the study and wrote an article titled "The Highway Section That Seems to Shrink." The article appeared in March 2010 and described the measurement discrepancies, driver reports, and the working group's findings. The article generated modest public interest, but no official follow-up. Vasquez also interviewed locals who lived near the highway. A gas station owner in Mazama, a man named Bernard Whitfield, told her that truck drivers regularly commented on the Washington Pass section feeling different. Some called it the quick stretch or the short pass. Whitfield said drivers had been mentioning this for years, long before the WS dot measurement discrepancy was discovered. He attributed it to the dramatic scenery. Drivers were so focused on the views that they didn't notice distance. A Forest Service employee named Dorothy Kowalski, who worked in the North Cascades National Park Complex, mentioned something else to Vasquez. She said, "The Skagit and Methal peoples had stories about the pass, not the modern highway, but the general area. The stories spoke of thin places where distances weren't fixed, where travelers could cover more ground than their steps should allow." Kowalski had heard these stories from tribal elders during cultural resource consultations. She didn't know details, only that the area had been considered unusual long before highways existed. Vasquez attempted to interview tribal representatives, but received no responses to her requests. The article ran without indigenous perspectives, noting only that local indigenous groups have historical associations with the area. State Route 20 continues to operate normally. The highway remains officially measured at 434.2 miles. No accidents or safety concerns have been attributed to the temporal anomalies. Drivers continue to report arriving slightly early when traveling through the Washington Pass section, though most attribute this to driving faster than they realized or misjudging distance. The GPS anomalies persist. Satellite tracking through the section continues to show brief signal gaps and positioning irregularities consistent with terrain interference. Surveyors accept this as normal for mountainous regions, but the pattern remains. Official records once said 437 miles. Modern measurements say 434.2, and the difference, 2.8 miles, corresponds almost exactly to the section where drivers consistently arrive 3 to 4 minutes early, where GPS signals falter, where memory feels thin, and where the highway seems to cover ground faster than speed and distance should allow, as if something about that stretch of asphalt and mountain pass compresses the space between points, folding distance in ways that instruments can measure but nobody can explain, leaving travelers to emerge on the far side of Washington Pass slightly ahead of where they should be, with odometers that read correctly, timestamps that don't quite add up, and the quiet certainty that they pass through something that shortened not just the highway, but the journey itself. Some rocks refuse to follow gravity, and nobody will say why. Lake Chelan occupies a glacially carved valley in the North Cascades of Washington State, stretching 55 miles from the town of Chelan at its southern terminus to the isolated community of Stehekin at its northern end. At its deepest point, the lake reaches 1,486 feet, making it the third deepest lake in the United States. The valley was scoured by repeated glaciations over millions of years, leaving behind a steep-sided trough filled with impossibly clear water. The Chelan people, for whom the lake is named, knew these waters as a place of boundaries, where the known world gave way to something older, where time accumulated in layers that didn't always settle in expected ways. The lake bottom has attracted scientific interest since the 1950s, when early bathymetric surveys revealed unusual sediment formations. Unlike most glacial lakes, where sediment accumulates in predictable horizontal layers determined by particle size and density, Lake Chelan showed irregularities that geologists initially attributed to underwater landslides or current patterns. These anomalies were noted but not extensively studied until 2002, when a research team from Central Washington University received a grant to conduct a comprehensive sediment core analysis of the lake. The research team was led by Dr. Margaret Kowalski, a sedimentologist with 15 years of experience studying glacial lake systems. Her team included 2 graduate students, Patricia Moreno and Thomas Rafferty, and a technician named Douglas Lindstrom who operated the coring equipment. Between June and September 2002, the team collected 37 sediment cores from various locations throughout the lake, focusing on the deepest sections where sediment accumulation would provide the longest historical record. The cores were transported to Central Washington University's Geology Laboratory in Ellensburg for analysis. Standard procedure involved visual examination, particle size analysis, chemical composition testing, and radiometric dating to establish chronology. Kowalski began the analysis in October 2002, starting with cores from the lake's northern end, near Stehekin. Core number 14, extracted from a depth of 1,200 feet, approximately 3 miles south of Stehekin, showed something that made Kowalski recalibrate her equipment and repeat the analysis. The sediment layers appeared inverted. Coarse particles, sand and small pebbles, sat above fine particles, clay and silt. This violated the fundamental principle of sediment deposition. Heavier particles settle first, lighter particles settle later. In still water, sediment naturally organizes by density, with the heaviest material at the bottom. Kowalski assumed the core had been accidentally inverted during extraction or transport, but Lindstrom's notes clearly indicated the core's orientation had been maintained from extraction through storage. The top of the core, as collected from the lake bottom, contained coarse material. The deeper layers contained progressively finer material. The sediment was deposited upside down. Kowalski examined other cores from the northern section of the lake. 8 of the 37 cores showed similar inversions, heavier particles above lighter ones in clear violation of gravitational sorting. The inverted sections weren't uniform across the cores. They appeared in distinct bands, suggesting specific events or periods when normal deposition had somehow reversed. In November 2002, Kowalski sent samples from the inverted layers to 3 independent radiocarbon dating laboratories: the University of Arizona's NSF Arizona AMS Laboratory, Beta Analytic in Miami, and the Center for Applied Isotope Studies at the University of Georgia. She wanted to establish when these anomalous deposits had occurred. The results, returned between January and March 2003, were incomprehensible. The coarse particles in the inverted layers returned dates of approximately 4,000 years before present. The fine particles directly beneath them, particles that should have been older, having been deposited first, returned dates of approximately 400 years before present. The same sediment layer contained material separated by 3,600 years, with the older material on top and the younger material below. Kowalski rechecked the sample labeling. She verified chain of custody. She considered contamination. None of these explanations fit. The samples had been carefully handled, properly labeled, and analyzed by reputable laboratories using standard techniques. The dates weren't errors. They were measurements that described an impossibility. Sediment deposited in reverse chronological order, with ancient material settling on top of recent material. In April 2003, Kowalski consulted with Dr. Raymond Gutierrez, a geophysicist at the University of Washington who specialized in sediment dynamics. She showed him the core photographs, the particle size analyses, and the dating results. Gutierrez examined the materials for 2 days before admitting he had no conventional explanation. Sediment simply doesn't behave this way. Gravity is consistent. Denser particles sink faster. Time moves forward. The Lake Chelan cores violated all 3 principles. Gutierrez suggested several hypotheses. Underwater currents creating uplift that selectively transported larger particles after smaller ones had settled. Bioturbation by organisms mixing sediment layers. Post-depositional chemical processes altering particle density. Kowalski tested each hypothesis. Current patterns in Lake Chelan weren't strong enough to lift and transport coarse sediment after fine sediment had settled. The inverted layers showed no signs of biological disturbance. The boundaries between layers were sharp, not mixed. Chemical analysis showed no density alterations that would explain the inversion. In June 2003, Kowalski prepared a paper for submission to the Journal of Sedimentary Research. The paper documented the inverted layers, the dating discrepancies, and the absence of known mechanisms that could explain the observations. She titled it Anomalous Vertical Sediment Distribution in Lake Chelan, Washington, a Challenge to Conventional Deposition Models. Before submission, she presented her findings at a Regional Geological Society of America meeting in Boise, Idaho, in July 2003. Her presentation included photographs of the cores, graphs showing particle size distributions, and tables of radiocarbon dates. The response from attending geologists ranged from skepticism to confusion. Several suggested she'd made methodological errors. Others proposed that the dating labs had contaminated samples. One geologist, a man from the U.S. Geological Survey named Walter Strand, asked pointed questions about sample handling and suggested that the cores might have been compromised during extraction. Kowalski defended her methodology. The cores had been carefully collected using standard equipment. Chain of custody had been maintained. 3 independent laboratories had produced consistent dates. The results were unusual, but the procedures had been rigorous. Strand took notes during her presentation, but made no further comments. In August 2003, Kowalski submitted her paper to the Journal of Sedimentary Research. The submission was acknowledged, and the paper entered peer review. In October 2003, she received reviews from 3 anonymous referees. 2 reviews raised methodological concerns but recommended revision and resubmission. The 3rd review was different. It stated, "The described sediment characteristics are inconsistent with known physical processes. The dating results suggest sample contamination or laboratory error. The paper should be rejected pending resolution of these fundamental methodological issues." Kowalski revised the paper, addressing the reviewers' concerns and providing additional documentation of her methods. She resubmitted in December 2003. In February 2004, the paper was rejected. The editor's letter stated that, despite the author's careful work, the reviewers remain concerned that the reported observations cannot be reconciled with established sedimentological principles, and therefore the paper is not suitable for publication in its current form. Kowalski was frustrated, but not deterred. She began preparing to submit the paper to a different journal. She also applied for additional funding to conduct more extensive sampling and analysis of Lake Chelan. On March 18, 2004, Kowalski received a certified letter from the U.S. Geological Survey. The letter, signed by a regional director whose name was partially redacted in later documents, informed her that sediment core samples from Lake Chelan were being requisitioned for federal geological assessment under provisions of 43 U.S.C. 31, a statute related to mineral surveys and public lands. The letter requested that Kowalski deliver all core samples, field notes, and analytical data to the USGS office in Seattle by March 30, 2004. Kowalski contacted Central Washington University's legal counsel. The university's attorney reviewed the statute cited in the letter and found that it typically applied to mineral resource assessments on public lands, not academic research samples from a lake. The attorney contacted the USGS to inquire about the legal basis for the requisition. The response, received in early April, stated that Lake Chelan fell within federal jurisdiction due to its proximity to North Cascades National Park, and that sediment analysis related to potential geological hazards and resource management concerns fell under USGS authority. Kowalski objected. Her research had no connection to geological hazards or resource management. She was studying sediment chronology. The university's attorney drafted a response challenging the requisition's legal foundation. Before the response could be sent, Kowalski received a phone call on April 9, 2004, from someone identifying himself as a USGS program coordinator. The caller stated that if Kowalski chose not to comply with the requisition, the USGS would request that the National Science Foundation review her research grant for methodology compliance issues. Kowalski's grant, which funded her graduate students and covered research expenses, came from the NSF. A review questioning her methodology could result in grant termination and damage her professional reputation. She consulted with her department chair, who advised cooperation. On April 15, 2004, Kowalski delivered all Lake Chelan core samples, field notes, photographs, and analytical data to the USGS office in Seattle. She retained copies of some documents but surrendered the physical cores and original field notes as requested. In May 2004, the National Science Foundation notified Kowalski that her grant was being reviewed for concerns regarding research methodology and data integrity raised by federal oversight agencies. The review was conducted by a panel of geologists who examined Kowalski's research protocols. In July 2004, the review concluded with findings that Kowalski's methodology contains irregularities in sample handling and analytical procedures that raise questions about data reliability. Kowalski was stunned. The review cited specific methodological concerns using technical terminology she didn't recognize. She shared the review document with colleagues in her department. None could identify the geological principles being referenced. The language appeared technical but didn't correspond to standard sedimentological or geochronological terminology. It was as if the review had been written in a specialized vocabulary that existed nowhere in published geological literature. The NSF terminated Kowalski's grant in August 2004. Her graduate students, Moreno and Rafferty, were reassigned to other projects. Kowalski was not prohibited from continuing research, but without funding and without access to her original samples, further investigation was impossible. In September 2004, a journalist from the Wenatchee World newspaper, a woman named Ellen Vasquez, learned about the grant termination and contacted Kowalski for an interview. Kowalski agreed, explaining the sediment inversions, the dating discrepancies, and the subsequent confiscation of her samples. Vasquez wrote an article that appeared in the October 3, 2004 edition, titled, "Lake Chelan Research Halted After Federal Intervention." The article generated modest regional attention, but no further investigation. The USGS declined to comment, referring inquiries to a public affairs office that provided only a written statement. The U.S. Geological Survey periodically conducts assessments of geological materials from federally managed or influenced lands to ensure a comprehensive understanding of natural resources and hazards. Specific research materials and data are managed in accordance with federal guidelines. Kowalski attempted to obtain copies of her confiscated samples and data through Freedom of Information Act requests in 2005. The requests were denied with a citation that the materials were a part of ongoing federal geological assessment and exempt from disclosure under 5 U.S.C. 552b(3), an exemption for materials specifically protected by other statutes. In 2007, Kowalski left Central Washington University to take a position at a private environmental consulting firm. She never published her Lake Chelan findings. When contacted by researchers in later years, she declined to discuss the project, saying only that the samples had been taken by federal authorities for reasons never explained. Moreno, one of the graduate students, completed her degree with a different research project and now works for the National Park Service in Alaska. Rafferty left geology entirely and became a high school science teacher in Oregon. Lindstrom, the technician, continued working in geological fieldwork, but has never discussed the Lake Chelan cores publicly. Lake Chelan remains open to research. Other geologists have studied its sediments since 2004, focusing on climate reconstruction and glacial history. None have reported sediment inversions or chronological anomalies. Whether this is because the anomalies don't exist in their sample locations or because researchers now avoid reporting such findings is unclear. The sediment cores collected by Kowalski remain in federal custody, presumably stored somewhere in USGS facilities. No publications have emerged from the USGS's stated geological assessment of the materials. The cores exist in bureaucratic limbo, confiscated under authority that remains vague, held for purposes that were never detailed, analyzed using methodology that produced reviews written in language that no geologist recognizes. And somewhere in those cores, preserved in the cold dark of federal storage, there are layers of sediment where heavy particles rest above light ones, where material 4,000 years old sits atop material 400 years old, where the fundamental rules of gravity and time appear to have reversed, as if something about Lake Chelan's depths allowed the past to settle on top of the present, creating an impossible stratigraphy that geologists measured but were not permitted to explain, leaving only the question of what happens at the bottom of a glacial valley when sediment forgets how to fall, and why the discovery of such a place is something federal authorities decided the scientific community wasn't supposed to document, discuss, or understand. There is a valley in Washington where radio waves go to die for exactly 8.3 seconds. Concrete sits in the upper Skagit River Valley, a small town of roughly 700 residents surrounded by the Cascade Range. The town earned its name from the cement industry that flourished here in the early 20th century, when the region's limestone deposits made it a center for construction materials. By the 1950s, the cement plants had closed, but the Skagit River continued to shape the area's identity through a series of hydroelectric dams built to power the growing populations of Seattle and western Washington. The valley itself is narrow, hemmed by steep mountains that rise 3,000 feet on either side, creating a natural corridor that funnels wind, water, and, according to decades of radio operator reports, electromagnetic silence. The indigenous Skagit and Sauk-Suiattle peoples knew this stretch of the river valley as a place where sound behaved strangely. Stories described echoes that arrived too late or not at all, and locations where voices carried impossible distances or vanished entirely. When Euro-American settlers arrived in the late 1800s, they attributed these accounts to superstition, though early logging camps occasionally reported difficulties with telegraph communications in specific areas of the valley. These reports were sporadic and poorly documented, dismissed as equipment problems or operator error. The modern radio gap was first systematically documented in November 1956 by an amateur radio operator named Walter Lindstrom, who lived in the nearby town of Sedro-Woolley. Lindstrom was an electrical engineer who operated a ham radio station from his home, maintaining regular contact with other operators throughout the Pacific Northwest. On November 14, 1956, he was transmitting to a fellow operator in Bellingham when his signal experienced what he described in his radio log as complete dropout lasting approximately 8 seconds, no static or interference, just silence. Lindstrom assumed atmospheric interference or equipment malfunction. He checked his transmitter and antenna. Both functioned normally. He attempted another transmission. The same thing occurred, approximately 8 seconds of silence. In the middle of his broadcast. He documented the time and frequency and continued monitoring. Over the next 3 weeks, Lindstrom identified a pattern. Any radio transmission, regardless of frequency, power level, or modulation type, that passed through or originated from a specific section of the Skagit River Valley near concrete, experienced an identical period of silence. The duration was consistent, 8.3 seconds, measured with stopwatch precision. Lindstrom shared his observations with other amateur operators in the region. By January 1957, 5 other operators had confirmed the phenomenon. A radio operator named Margaret Kowalski in Mount Vernon documented the silence affecting transmissions on multiple amateur radio bands. Another operator, Thomas Rafferty in Anacortes, reported that the silence occurred even when using different antenna configurations and transmission modes. The gap wasn't frequency dependent or power dependent. It affected all electromagnetic radiation passing through a specific geographic corridor. What made the phenomenon particularly unusual was its precision. Radio interference typically varies. Signal strength fluctuates. Silence duration changes based on atmospheric conditions or terrain. The concrete radio gap never varied. 8.3 seconds of complete silence occurring at the same point in every transmission that passed through the valley, regardless of weather, time of day, or solar activity. In March 1957, Lindstrom contacted the Federal Communications Commission to report the anomaly. The FCC response, dated April 2, 1957, acknowledged receipt of his report and stated that localized propagation anomalies can occur in mountainous terrain due to reflection, refraction, and absorption of radio waves by topographic features. The letter suggested that the Skagit River Valley's steep-sided geography likely created unusual signal paths that resulted in perceived gaps in transmission. No investigation was proposed. Lindstrom wasn't satisfied with this explanation. He understood radio propagation. Terrain could block, reflect, or attenuate signals, but it didn't create precise 8.3-second gaps across multiple frequencies simultaneously. In May 1957, he began a more systematic study, coordinating with operators throughout the region to triangulate the exact geographic boundaries of the dead zone. The results, documented in a self-published report Lindstrom circulated in August 1957, showed that the radio gap affected a corridor approximately 3 miles long and half a mile wide, centered on the Skagit River between Concrete and the town of Rockport. The corridor aligned roughly with the location of the Upper Baker Dam, which had been completed in 1959. Wait, that date was wrong. Lindstrom's report was from 1957. The Upper Baker Dam had been completed in 1959, but the radio gap had been documented starting in November 1956. The timeline mattered. Lindstrom noted in his report that construction on the Upper Baker Dam had begun in 1955. Major excavation and concrete pouring occurred throughout 1956. The radio gap appeared to coincide with active dam construction, though Lindstrom couldn't establish a direct causal relationship. He suggested that the construction might have altered local geology in ways that affected electromagnetic propagation, though he acknowledged this was speculative. By 1960, the radio gap had become well known among amateur operators in the Pacific Northwest. Some avoided the frequency ranges that passed through the concrete corridor. Others used it as a curiosity, a reliable dead zone where they could demonstrate the phenomenon to skeptical listeners. The gap remained consistent, 8.3 seconds every time without exception. In 1973, a graduate student in electrical engineering at the University of Washington named Patricia Moreno learned about the radio gap while researching her thesis on electromagnetic propagation in mountainous terrain. She contacted Lindstrom, who was still documenting the phenomenon 17 years after his initial observations. Moreno obtained permission from the university to conduct field measurements in the Skagit Valley during the summer of 1973. Her equipment included spectrum analyzers, directional antennas, and oscilloscopes capable of measuring signal characteristics with millisecond precision. She established measurement stations at multiple points along the valley and transmitted controlled signals at various frequencies. Her results confirmed Lindstrom's observations. Every transmission experienced an 8.3-second gap when passing through the corridor. The gap didn't attenuate the signal, it silenced it completely. Before the gap, signal strength was normal. After the gap, signal strength returned to exactly the same level. It was as if the 8.3 seconds simply didn't exist for electromagnetic radiation. Moreno's thesis, completed in 1974, included a detailed analysis of the phenomenon. She ruled out atmospheric effects, ionospheric reflection, and terrain blocking. The gap occurred even with line-of-sight transmission paths. It affected signals from satellites passing overhead. It appeared to be a property of the space itself within that specific geographic corridor, a region where electromagnetic radiation ceased to propagate for exactly 8.3 seconds before resuming normally. Moreno's thesis committee accepted her work but expressed skepticism about her conclusions. One committee member noted that the described phenomenon lacks a physical mechanism consistent with established electromagnetic theory. Moreno had no mechanism to propose. She'd measured the effect repeatedly and rigorously, but she couldn't explain it. She submitted a paper based on her thesis to the Journal of Geophysical Research in January 1975. The paper was rejected in March with a reviewer comment stating that the reported observations, while apparently careful, describe effects that are physically implausible without additional evidence of measurement artifact or environmental factors not adequately controlled. Moreno attempted to interest other researchers in the phenomenon. She contacted the National Radio Astronomy Observatory, suggesting that the radio gap might have implications for understanding electromagnetic propagation. She received a polite reply, stating that the observatory's research focused on extraterrestrial radio sources and couldn't accommodate studies of terrestrial propagation anomalies. In 1982, a telecommunications engineer named Douglas Rafferty, working for a cellular phone company, conducted a site survey in the Skagit Valley for potential cell tower placement. His survey equipment, which included sophisticated radio frequency mapping tools, detected the 8.3-second gap. Rafferty reported it to his company as a potential interference issue that would affect cell phone service in the area. The company consulted with the FCC and submitted a technical inquiry about known propagation anomalies in the region. The FCC response, dated June 1982, stated that localized signal variations in mountainous terrain are common and typically do not significantly impact commercial telecommunications infrastructure. The company proceeded with tower placement, accepting that the concrete corridor would have a brief service gap that customers would likely attribute to terrain or distance from towers. In 1998, with the proliferation of GPS technology, a different aspect of the radio gap became apparent. GPS receivers in the concrete corridor experienced brief signal loss, exactly 8.3 seconds when vehicles or aircraft passed through the affected area. The GPS satellites broadcast on specific radio frequencies. Those frequencies experienced the same gap as all other electromagnetic radiation in the corridor. An aviation safety researcher named Dr. Raymond Gutierrez at the FAA's Technical Center in New Jersey learned about GPS dropouts in the concrete area through pilot reports. In 2001, he requested data from the FAA's Seattle Center on GPS reliability in the region. The data confirmed consistent 8.3-second GPS outages in the concrete corridor. Gutierrez found this concerning. GPS was becoming critical infrastructure for aviation navigation, and predictable signal loss, even brief signal loss, warranted investigation. He contacted researchers at the University of Washington and the U.S. Geological Survey to inquire whether geological or atmospheric conditions in the Skagit Valley might explain GPS interference. The USGS response, dated March 2002, stated that no known geological features in the specified region would produce the described electromagnetic effects. The University of Washington researchers suggested that the GPS outages might be caused by multipath interference from surrounding terrain, though they acknowledged that 8.3-second duration was unusually consistent for such effects. Gutierrez requested permission from the FAA to conduct a field study in 2003. His request was denied with a notation that the described GPS outages fall within acceptable parameters for mountainous terrain and do not warrant dedicated investigation resources. The radio gap continues. Amateur operators still document it. GPS receivers still lose signal for 8.3 seconds. Cell phones briefly lose service. All radio frequencies, all electromagnetic radiation experiences the same silence in the same corridor at the same duration. Multiple researchers have attempted to study it systematically. Equipment failures have consistently complicated these efforts. In 2007, a team from Portland State University attempted to place permanent monitoring stations in the corridor. 4 separate data loggers from different manufacturers experienced synchronized failures. They stopped recording simultaneously at intervals that appeared random but were later calculated to be multiples of 8.3 seconds. The team's field notes, preserved in university archives, describe the failures as unprecedented in pattern and timing. In 2015, a journalist from the Seattle Times, a woman named Ellen Vasquez, wrote an article about the radio gap. The article interviewed amateur operators, telecommunications engineers, and local residents. One resident, a man named Bernard Kowalski, who'd lived in concrete since the 1940s, told Vasquez that the valley had always been strange with sounds. He described standing in specific locations where he could shout and hear no echo, or where conversations seemed to drop words randomly. He said these locations predated the dam construction and had been noted by old-timers who'd logged the valley before World War II. The article generated regional interest but no official follow-up. The FCC, when contacted for comment, referred to their 1957 assessment, localized propagation anomalies caused by terrain. The FAA stated that GPS reliability in the region met acceptable standards. No agency expressed interest in further investigation. The Upper Baker Dam operates normally, generating power as it has since 1959. Its environmental impact statement, reviewed by researchers seeking possible explanations for the radio gap, contains no mention of electromagnetic effects, radio frequency interference, or unusual propagation conditions. The dam is concrete and steel, situated in a river valley, performing exactly the function for which it was designed. And every radio wave that passes through the concrete corridor vanishes for 8.3 seconds. Not scattered, not absorbed, not reflected, just gone, as if passing through a space where electromagnetic radiation briefly ceases to exist, where 8.3 seconds of transmission time is systematically removed from every signal, every frequency, every device, with precision that suggests not random interference, but something deliberate, something that began in 1956 during the construction of a dam, whose official documentation contains no hint that anyone expected electromagnetic silence to be one of its effects, leaving only the measurements, the consistent loss, and the question of what exists in that valley corridor that knows exactly how long to hold radio waves in nothingness before releasing them unchanged on the far side, 8.3 seconds later, as if nothing had happened at all. Some trees don't just record time, they measure it in sequences that shouldn't exist in nature. Mount Hood National Forest encompasses over 1 million acres of wilderness in northern Oregon, dominated by the 11,249-foot volcanic peak that gives the forest its name. The lower elevations support some of the oldest Douglas fir stands in the Pacific Northwest, trees that germinated in the 1500s and witnessed the entire arc of European contact and settlement. These ancient forests have been studied extensively by dendrochronologists, scientists who read tree rings to reconstruct climate history, fire patterns, and ecological change. The work is meticulous and well established. Growth rings follow predictable patterns. Wide rings in favorable growing years, narrow rings in drought or stress years. The variation appears random but correlates consistently with climate records. Trees record environmental conditions, not mathematical sequences. The anomalous tree stands in the salmon huckleberry wilderness, a protected area on Mount Hood's western slope. It's located approximately 6 miles from any maintained trail, accessible only by bushwhacking through dense undergrowth and crossing 2 seasonal streams. The area sees few visitors. Forestry students conducting old-growth surveys typically work in more accessible locations. The only reason the tree was discovered at all was because of a navigation error. In September 2009, 3 forestry graduate students from Oregon State University, Margaret Kowalski, Thomas Rafferty, and Patricia Lindstrom, were conducting a survey of old-growth stands as part of a research project on carbon sequestration in ancient forests. They were using GPS units to navigate between predetermined sample locations. On September 17th, Rafferty's GPS unit malfunctioned, displaying coordinates that placed them roughly half a mile from their intended position. Rather than backtrack immediately, the students decided to take preliminary samples from their actual location to avoid wasting the day's field work. They selected a Douglas fir that appeared to be approximately 400 years old based on its diameter and bark characteristics. Following standard procedure, they used an increment borer, a specialized tool that extracts a pencil-thin core of wood from the tree without causing significant damage. Kowalski operated the borer while Rafferty and Lindstrom recorded data. The core sample, roughly 16 inches long and containing the tree's complete growth history from bark to center, was extracted successfully and placed in a protective sleeve for transport back to the university. Initial examination of the core occurred in the Oregon State University Dendrochronology Lab on September 23, 2009. Kowalski mounted the core and sanded it smooth to make the growth rings visible under magnification. What she saw made her assume she'd made an error in the sanding process. The rings showed unusual patterns, clusters of varying density that repeated in what appeared to be regular intervals. She resanded the core and examined it again. The patterns persisted. She called Rafferty and Lindstrom to review the sample. All 3 observed the same thing. The growth rings weren't simply varying in width based on growing conditions. They appeared to organize into distinct groups separated by periods of suppressed growth. Kowalski counted the rings in each group: 3 rings of dense growth, followed by suppressed growth, then 5 rings of dense growth, more suppression, then 7, then 11, then 13. The pattern repeated across the entire core sample. The students consulted their advisor, Dr. Douglas Whitmore, a dendrochronologist with 30 years of experience. Whitmore examined the core on September 25th and confirmed the pattern. The rings were organized in sequences of prime numbers: 3, 5, 7, 11, 13, 17, 19, 23. The sequence repeated multiple times across the 400-year growth record. Whitmore had never seen anything like it. Growth ring patterns reflect environmental variables: precipitation, temperature, competition from neighboring trees, insect outbreaks, fire damage. They don't organize into mathematical sequences, particularly not prime number sequences. Whitmore suggested several possible explanations: periodic environmental stress occurring at intervals that happen to match prime numbers, selective herbivory by insects with prime-numbered life cycles, or measurement error creating the appearance of pattern where none existed. He recommended statistical analysis to determine whether the pattern was genuine or an artifact of selective observation. Kowalski conducted the statistical analysis in October 2009. She measured every ring width in the core sample, entered the data into dendrochronology software, and tested for periodicity. The results were unambiguous. The prime number pattern was statistically significant, far beyond chance occurrence. The probability of such a pattern arising from random environmental variation was less than 1 in 10 million. The tree's growth rings were organized in a way that violated every known principle of dendrochronology. Whitmore submitted a paper to the journal Dendrochronologia in November 2009, describing the anomalous growth pattern and requesting input from the dendrochronology community. The paper included photographs of the core sample, detailed measurements of every ring, and statistical analyses demonstrating the pattern's significance. The paper was carefully worded, presenting the observation without claiming to explain it. The journal's response came in January 2010. The paper was rejected by all 3 peer reviewers. The rejection letters were unusual. One reviewer wrote, "The described pattern cannot result from natural processes. The authors should examine their sampling and measurement procedures for sources of contamination or error." Another stated, "The core sample appears to have been altered post-extraction. I recommend the authors verify chain of custody and consider whether the sample could have been tampered with." Whitmore was disturbed by these responses. The sample had been extracted under controlled conditions with multiple witnesses. It had been stored in a locked laboratory. Chain of custody was well documented. There was no opportunity for tampering. He wrote to the journal editors requesting clarification on what evidence suggested tampering. The editors replied that the reviewers' concerns spoke for themselves and that the paper was not suitable for publication without addressing fundamental questions about sample integrity. In February 2010, Whitmore sent portions of the core sample to 3 separate dendrochronology laboratories for independent analysis. One at the University of Arizona's Laboratory of Tree Ring Research, one at Columbia University's Tree Ring Lab, and one at the Swiss Federal Institute for Forest, Snow, and Landscape Research. He included no information about the prime number pattern, asking only that each lab verify the ring measurements and assess whether the sample showed signs of damage or alteration. The results returned between March and May 2010 were consistent and baffling. All 3 labs confirmed the ring measurements. All 3 noted the unusual density patterns. All 3 concluded that the sample showed signs of post-extraction modification or evidence of tampering. The University of Arizona report stated, "The observed density variations are too regular to result from natural growth processes and suggest artificial enhancement or selective treatment of the wood sample." Whitmore was at a loss. He'd extracted the core himself in the field. He'd maintained custody throughout. No treatment or enhancement had been applied beyond standard sanding for microscopy. He contacted each lab requesting specifics on what evidence indicated tampering. None could provide concrete examples. The wood showed no chemical traces, no cutting marks, no glue or filler. The tampering assessment was based solely on the impossibility of the pattern itself. Because such a pattern couldn't occur naturally, the labs concluded it must have been created artificially. In June 2010, Whitmore decided to return to the tree and extract a second core sample from a different side. If the pattern was an artifact or a measurement error, a second sample should show normal growth rings. If the pattern was genuine, however impossible, it should appear in the second sample as well. He assembled a team consisting of himself, Kowalski, Rafferty, Lindstrom, and Dr. Raymond Gutierrez, a forest ecologist from the University of Washington, invited specifically to serve as an independent observer. On June 19, 2010, the team hiked to the tree's location using the GPS coordinates recorded from the original visit. They couldn't find the tree. The GPS coordinates placed them in the correct general area. The terrain matched photographs and field notes from the original visit, but the specific tree was not where the coordinates indicated. They spent 3 hours searching, examining every large Douglas fir within a quarter-mile radius. None matched the photographs. None showed the distinctive bark patterns Kowalski had documented. The tree had vanished, or they were in the wrong location despite GPS confirmation. Rafferty suggested his original GPS malfunction might have recorded incorrect coordinates. They expanded their search over the following 2 days, covering a 1-mile radius around the recorded position. They found many old-growth Douglas firs. None was the tree they'd sampled. On June 21st, the team returned to campus without a second sample. Whitmore filed a report with the Forest Service in July 2010, describing the original discovery and the unsuccessful return visit. He requested assistance in relocating the tree, suggesting that improved GPS coordinates or aerial imagery might help. The Forest Service response, dated August 2010, stated that the Salmon Huckleberry Wilderness contained extensive old-growth Douglas fir stands, and that, without more specific location data or distinctive physical markers, relocating a single tree is not feasible given available resources. In September 2010, Whitmore was contacted by someone identifying himself as representing the U.S. Forest Service Pacific Northwest Research Station. The caller asked about the core sample and whether Whitmore still possessed it. Whitmore confirmed he did. The caller suggested that the sample might be of interest for specialized analysis related to forest health monitoring and requested that Whitmore provide it to the research station. Whitmore asked what specific analysis was planned. The caller provided vague answers about comprehensive wood tissue studies. Whitmore declined to surrender the sample. In November 2010, Oregon State University's Office of Research Integrity contacted Whitmore to inform him that questions had been raised about his dendrochronology research and that an informal inquiry would be conducted. The inquiry, completed in January 2011, found no evidence of research misconduct, but noted that the extraordinary claims regarding prime number sequences in tree growth rings have not been substantiated by independent verification and have raised concerns within the dendrochronology community about methodology and data interpretation. Whitmore retired from Oregon State University in 2012. He donated his research materials, including the anomalous core sample, to the university's archives. In 2015, a graduate student attempting to locate the sample for a historiographical project on disputed scientific findings discovered that it was missing from the archived materials. University archivists searched for 2 months but could not locate it. The sample was listed as lost or misfiled during collection transfers. Kowalski, Rafferty, and Lindstrom all completed their degrees and moved into forestry careers. When contacted by researchers in later years, all three confirmed the original observations but declined to discuss the matter in detail. Kowalski said only that, "We found something unusual, documented it properly, and were told it couldn't be real." Gutierrez, the independent observer who'd accompanied the return trip in 2010, wrote a brief account of the experience. In a 2016 essay on scientific anomalies, he described the unsuccessful search for the tree and noted, "The most disturbing aspect wasn't that we couldn't find the tree. It was that the landscape itself seemed subtly wrong, as if we were in a location that resembled but wasn't quite the place shown in the photographs." The Mount Hood National Forest continues to be studied by dendrochronologists. No other trees showing prime number growth patterns have been reported. The original core sample, if it still exists, remains unlocated. The tree itself, if it still stands in the Salmon Huckleberry Wilderness, has not been rediscovered despite the GPS coordinates being publicly available in Whitmore's archived field notes. What remains is testimony. Photographs of a core sample showing impossible patterns and laboratory reports from 3 institutions agreeing that the sample must have been tampered with because the alternative, that a tree spent 400 years growing in sequences of 3, 5, 7, 11, 13, 17, 19, 23, would require explanations that dendrochronology has no framework to provide, The tree counted in prime numbers across 4 centuries of growth, organizing its annual rings according to a mathematical sequence that has no relationship to climate, competition, or any known biological process, until someone documented the pattern and the tree vanished from the coordinates where it had stood, leaving behind only a core sample that 3 universities examined and called impossible, a sample that has itself now disappeared, and the question of what grows in the old forests of Oregon that knows mathematics, that counts in primes while recording centuries in wood, and that, when discovered, removes itself from the landscape, as if the act of documentation was itself an intrusion into something that was never supposed to be found or measured or understood by anyone who thought trees were only keeping records of rain and sun and the passive accumulation of years. Some photographs develop long after they're taken, capturing people who weren't there yet. Image Lake sits at 6,100 feet elevation in the Glacier Peak wilderness of Washington's North Cascades. A glacial tarn nestled below Miners Ridge with views of Glacier Peak's 10,541-foot summit reflected in its waters. The trail to Image Lake covers roughly 18 miles from the nearest trailhead, gaining over 3,000 feet in elevation through old-growth forest and alpine meadows. The route is remote enough that hikers typically encounter fewer than a dozen other people during a multi-day trip. The lake itself has been a destination for photographers since the 1930s, drawn by the symmetry of peak and reflection, the isolation, and the quality of light at high elevation. Indigenous Sauk-Suiattle and Stillaguamish peoples knew the area as a place where visions occurred, where the boundary between what was and what would be became thin enough to see through. The photograph was discovered on July 28, 2012, by a hiker named Margaret Kowalski from Seattle. She was descending from Image Lake toward the Canyon Creek trailhead, approximately 2 miles from the lake, when she noticed something white partially buried in the trail. She assumed it was litter and stopped to pick it up. It was a Polaroid photograph, weathered and faded, but still recognizable. The image showed a section of trail that Kowalski immediately recognized. She'd passed the same spot roughly an hour earlier. The photograph's angle suggested it had been taken from the trail itself, looking upslope toward a distinctive rock outcrop that marked a switchback. What made Kowalski pause was the people in the photograph. 37 individuals stood in the background, arranged in what appeared to be a loose formation across the trail and the adjacent meadow. They weren't posed like a group photo. They seemed to be standing naturally, as if they'd simply stopped walking and turned toward the camera. Some were in hiking clothes. Others wore what looked like casual streetwear. A few appeared to be in dated clothing, bell-bottom jeans, shirts with wide collars, suggesting the photograph was from the 1970s or early 80s. Kowalski photographed the Polaroid using her smartphone and posted the image to a Pacific Northwest hiking forum on July 30th, 2012, asking if anyone knew the backstory. She described finding it on the trail and noted that the location was recognizable as the switchback below Image Lake. She asked whether the photograph might be from a large, organized hike or wilderness program from decades past. The responses began within hours and quickly became unsettling. The first commenter, identifying himself as Thomas Rafferty from Portland, stated that he recognized himself in the photograph, third from the left wearing a blue jacket. He was certain. It was him based on the jacket, his build, and a distinctive patch on the sleeve. But he'd never hiked to Image Lake in a large group, and he'd never seen this photograph before. A second commenter, Patricia Lindstrom from Bellingham, claimed she was also in the photograph, seventh from the right, with a red backpack. She described specific details. The backpack was a model she'd owned since 2008, and she could identify a repair patch on the shoulder strap visible in the photograph. She'd hiked to Image Lake multiple times, but never with more than 3 companions. By August 2, 2012, 14 people had claimed to recognize themselves in the photograph. All provided specific identifying details: clothing, gear, physical characteristics, scars, or tattoos visible in the image. None could explain when the photograph was taken. None remembered being part of a group of 37 people on that trail. Several noted that they appeared in the photograph wearing clothing they currently owned, and one commenter pointed out that the photograph quality and fading suggested it was decades old, yet the clothing and gear visible on many figures appeared contemporary. On August 5, 2012, a forum member named Douglas Whitmore, who identified himself as a photography collector, requested to examine the original Polaroid. Kowalski agreed and mailed it to Whitmore's address in Tacoma. Whitmore posted his analysis on August 12th. He identified the photograph as genuine Polaroid film stock, specifically Polaroid SX70x0, which had been manufactured between 1972 and 2006. The photograph showed age-appropriate fading and emulsion degradation consistent with decades of exposure to light and moisture. Whitmore noted one detail that disturbed him. The film's date code, visible on the photograph's border, indicated manufacture in 1979. This created an impossibility. If the photograph was taken in 1979, several of the people who claimed to recognize themselves would not have been born yet. Rafferty, the first commenter, was born in 1985. Lindstrom was born in 1991. At least 6 of the 14 individuals who identified themselves were too young to appear in a photograph from 1979. Whitmore suggested several explanations. The photograph might be a composite, digitally created, and printed to look like vintage Polaroid film. The people recognizing themselves might be mistaken, seeing resemblance rather than actual identity, or the date code might have been misread. He submitted the photograph to a forensic document examiner named Dr. Raymond Gutierrez in Seattle, requesting professional analysis. Gutierrez's report, completed in September 2012, confirmed the photograph was genuine Polaroid film from the 1970s, showed no evidence of digital manipulation or composite printing, and contained no indicators of modern reproduction techniques. The emulsion chemistry, paper stock, and degradation patterns were all consistent with a photograph taken approximately 30 to 35 years prior. Gutierrez also noted something unusual. Portions of the photograph appeared less degraded than others. The figures in the background, the 37 people, showed sharper detail and less fading than the landscape they stood within. The trail, rocks, and vegetation showed age-appropriate degradation. The people looked as if they'd been photographed more recently, despite being part of the same exposure. In October 2012, a journalist from the Seattle Times, a woman named Ellen Vasquez, wrote an article about the photograph titled "Mystery Polaroid Sparks Online Debate About Time and Memory." The article interviewed several of the individuals who claimed to recognize themselves, forensic experts who'd examined the photograph, and psychologists who specialized in memory and facial recognition. The article presented no conclusions, but noted the tension between physical evidence, a photograph from 1979, and testimonial evidence, 14 people recognizing themselves in poses and clothing from the 2010s. The article attracted attention from academic researchers. Dr. Bernard Kowalski, a cognitive psychologist from the University of Washington, proposed that the phenomenon represented pareidolia combined with suggestion. People seeing resemblance in ambiguous figures and convincing themselves of identity through collective reinforcement. But Kowalski's theory struggled to explain the specific details the commenters provided: the model and condition of gear, the exact placement of patches and repairs, the identification of personal items like water bottles and watch brands visible in the photograph. In December 2012, Rafferty, the first person to claim recognition, made a decision that would complicate the mystery further. He hiked to Image Lake, specifically to the switchback where the photograph appeared to have been taken. He brought a friend, Michael Brennan, who photographed him standing at the same location, attempting to recreate the pose from the Polaroid. When Brennan's photographs were later compared to the Polaroid, the resemblance was striking. Rafferty's stance, the position of his arms, even the angle of his head matched almost exactly. But the recreation was in 2012. The Polaroid was from 1979. Rafferty described the experience in a forum post dated December 18, 2012. Standing there felt familiar in a way I can't explain. Not like I remembered being there before, but like I was completing something that had already been recorded. It was deeply unsettling. In January 2013, Margaret Kowalski received an email from someone identifying himself as representing Kodak's corporate archives. The email requested the return of the photograph for historical documentation purposes related to vintage film stock preservation. Kowalski, who'd received the photograph back from Gutierrez after his analysis, declined. She'd become protective of it, sensing it represented something more significant than a simple photographic curiosity. In March 2013, the hiking forum where the photograph had first been posted experienced a data corruption event. The thread discussing the photograph disappeared, along with all comments and user contributions. Forum administrators described the corruption as selective and inexplicable. Other threads from the same time period remained intact. Attempts to recover the data from backups failed. The backups themselves showed signs of corruption specifically affecting that thread. Kowalski had saved screenshots of the original discussion, including the names and claims of the 14 people who'd identified themselves. She attempted to contact them directly using information from their forum profiles. 8 responded. 6 accounts no longer existed, not deactivated or deleted, but showing no record of ever having been created. Forum administrators confirmed that the usernames Patricia Lindstrom, Douglas Whitmore, and 4 others had no registration records, despite multiple people remembering their posts and contributions. In June 2013, a backpacker named Dorothy Strand found something while hiking near Image Lake. A camera half buried near the same switchback where Kowalski had found the photograph. The camera was a Polaroid SX70, the model that used the Time Zero film. The camera was weathered and non-functional, its mechanisms corroded by decades of exposure. Strand reported the find to the Forest Service Ranger Station at Darrington. The ranger, or a woman named Sarah Moreno, logged the camera as found property, but noted in her report that similar cameras had been found in the area over the years. Hikers often lost or abandoned equipment on remote trails. Moreno mentioned something else to Strand that didn't make it into the official report. She said that in her 6 years working the Glacier Peak Wilderness, she'd received multiple reports of hikers encountering large groups on the Image Lake Trail. Groups that appeared suddenly, stood in formations as if posing, then dispersed before the reporting hiker could reach them. Moreno had investigated several of these reports and found no evidence of large groups camping or hiking in the area. The reports were sporadic but consistent enough that Moreno had noted them in her personal journal, though not in official documentation. The photograph remains in Kowalski's possession. She's declined multiple requests to donate it to museums or historical societies. In 2018, she agreed to have it examined by a new generation of forensic imaging specialists, using techniques unavailable in 2012. The analysis, conducted by a private firm specializing in historical photograph authentication, confirmed everything previous examinations had found. Genuine Polaroid film from 1979, no evidence of manipulation, and the unsettling discrepancy in degradation patterns between the figures and the landscape. The analysis added one new detail. Using high-resolution imaging, the specialists identified that several of the 37 figures were holding objects that appeared to be smartphones, rectangular devices held at angles consistent with taking photographs. Smartphones didn't exist in 1979. The specialists noted this in their report, but offered no explanation beyond suggesting the objects might be other items that coincidentally resembled phones. Rafferty, Lindstrom, and several others who identified themselves in the photograph have maintained contact. In 2020, they organized a group hike to Image Lake, specifically to the switchback. 8 people participated, including Kowalski, who brought the original photograph. They stood at the location, attempting to match the positions of figures in the image. A 9th hiker, a woman named Angela Torres, who was passing through and stopped to ask what they were doing, agreed to photograph them from the approximate position where the original Polaroid had been taken. Torres's photographs, taken with a digital camera, show the 8 hikers standing in formation. When compared to the Polaroid, the positions match almost exactly, but the Polaroid shows 37 people. The 2020 photographs show 8. Torres described the experience in an email to Vasquez, the journalist who'd written the original article. They were trying to recreate something, but it felt more like they were fulfilling it. When I looked through the viewfinder for just a moment, there seemed to be more people than there actually were. When I looked up from the camera, there were only the 8. I took the photos quickly and left. The Polaroid continues to exist, cataloged informally as the Image Lake photograph among those who've followed the mystery. It shows 37 people standing on a trail in 1979, at least 14 of whom recognize themselves despite being too young or wearing clothing that didn't exist when the photograph was taken, captured on film that degraded normally except for the figures themselves, who remain sharp and clear as if they were photographed yesterday, or perhaps as if they haven't been photographed yet, standing in formation across time, waiting in a frame that developed 33 years before some of them arrived at the location to stand exactly where the photograph shows them standing, creating a loop of documentation that has no beginning. Just a Polaroid from 1979 showing people from 2012, found by someone in 2012 who posted it online, where those same people recognized themselves and traveled to the place to stand where they'd already been standing before they were born, while something at Image Lake continues taking photographs that develop across decades, collecting people who will eventually find themselves in images that predate their presence, drawn to a switchback in the North Cascades where a camera was found buried in the trail, a camera that once held film from 1979, film that somehow knew who would be walking there 33 years later, and captured them anyway, waiting in a Polaroid for them to find themselves and understand that they'd already been seen.